Yeah, started a little bit late, so sorry about that. We're going to get started. We've got a full day of talks and developer sessions that we want to go through with you guys. We're going to start with a little bit of background information from a couple people from RDXWorks. My name is Matthew Hine. I'm the Chief Product Officer at RDXWorks. RDX is the creators of the Radix network protocol. We're going to be talking about that, but also we're going to be talking about just DeFi, Web3 in general, and then we're going to get into some coding sessions this afternoon, and we're going to lead anybody that wants to follow on their laptop. We're going to be actually writing some real Web3 DeFi code in Scripto, so that'll be exciting, I think. Before we got into some of that stuff, first I wanted to introduce Farah from RDXWorks. She's our head of recruiting. We are recruiting, and she's got a couple things she wants to say to you.
I think this works. Yes. Perfect. Hi, everybody. Actually, I realized that's from The Simpsons. Thanks again for coming. It's really great to see people here. I'm sure more will turn up throughout the day. As Matt said, I am the head of recruitment here at RDXWorks. Just to give you a little bit of background, the last 18 months has really been amazing for the business. When I joined April last year, there was 23 of us. As of Monday, there's 66, and we have 10 more people due to start with us. So we've really tripled massively over the last 12 months, which has been really amazing. We do have a global team, so we have people in the UK. I'm Scottish, if the accent didn't put you off. But we've got people in the UK, Europe, US, Canada, Hong Kong, Argentina, literally everywhere. We truly have a global workforce, and it really kind of adds to who we are as well. As we grow, it's really important that we stick to our company values. And if you haven't seen them, so if you're new to RDXWorks or the Radix network, you know, these are our core values. So it's ask for help and get shit done. Be excellent to each other. Those who know Bill and Ted will have heard that before. Take the initiative. You've got this. Do the right thing, not the easy thing, and strong opinions loosely held. So if these resonate with you and you like what you see today, once you've used Scripto, then please grab me throughout the day. We can talk about the opportunities that we've got, or if you don't really want to talk to me, which I will not take offense, everything's on our website, so you can see all of our live vacancies. We've got hiring plans for an additional 70 people over the next 12 months. So we really are growing, and that's not just in development, it's across the board, you know, from operations, finance, absolutely everything. So yeah, thanks again, and I will hand you back over to Matt. Thanks.
Okay, so we're going to start off with a couple of talks, give you some background. You know, we're big believers in the potential for cryptocurrency, the potential for DeFi and Web3 to remake the world in a positive way. We've got, you know, we want to, for people that are new to this space, we want to give you kind of a primer on why we think this is so important, why we think it's so fundamental, not just sort of as at a conceptual level, but you know, really what this does for the world. So we're going to have a couple of talks that we're going to go through. One thing I wanted to, yeah, you've got it up here. So we've got Slido set up here. We're going to be doing Q&A sessions throughout the day. We're going to do a little bit after these intro keynotes. We're going to be doing Q&As as we go through the technical things. So anybody here or anybody that's following on the live stream that I believe we're doing, if you scan that QR code, it'll allow you to get to Slido, and you can enter your questions in there. You can even vote on other people's questions, I think, so we float the most important stuff to the top. And we'll be going through those questions as we go. And I'm sure we'll also have some time for some kind of live questions. One thing we may do is we're going to do, this first section about kind of Radix in general, about DeFi in general. That would be a good time to ask questions you have about sort of just Radix as a project and everything. We can also hit some of that at the end of the day. Once we move into the technical sessions, we're going to be really focusing on technical questions to make sure that people that want to learn Scripto can get those questions answered. So first talk of the day, I want to introduce Piers Ridyard. He's the CEO of RDXWorks, and he's going to be talking about why we think this is the biggest opportunity for developers going right now.
Hey guys. Hey, all right, I've got the loudest mic, that's cool. Does this, let's see if this works. Matthew, it doesn't work.
I failed to monetize my charge.
All right, cool. CEO of a tech company, can't use tech. Great. All right, so let's just start with the sort of really basic of why Radix builds, why RDX builds Radix. Like, ultimately, like, we believe, I think this is a thing that crypto believes in general, but like, we strongly believe that finance today is failing users in 1,000 different ways. And like, these are generally small ways, but they all add up. It could be that like, transferring your pension takes like a month and like 1 million pieces of paper, or getting a mortgage is the most painful adult experience you can have aside from having major surgery, or like sending money like across the world, or even like just to Canada, costs a bunch of money that it shouldn't. And like, all of this is because finance is kind of built up as this like local first business, right? Because the world wasn't global before the internet. And finance was built for its, like, that's why we had local banks, that's why we had farmers' banks and stuff like that. And as a result of that, you have this weird archipelago of badly interconnected islands that just create continuous bad experiences for everyone. And so our vision, like what we are striving to create, the change that we want to create in the world, is a radically better financial system. Like, that's ultimately what we think this technology, like public ledgers, decentralized ledger technology is good for, is possible to create something that can serve people in a way that we're kind of grown to expect in other areas of our lives and continually like bang up against when we interact with finance. And what's that going to look like? So we believe, much like the rest of the crypto world, that decentralized finance is going to eat traditional finance. And it's going to eat traditional finance because when you look at what the #1 reason that the global financial system exists, it is the efficient allocation of capital. And what we've already seen in decentralized finance is an incredible influx of capital, because there is so much yield, there's so much opportunity, there's so many things that can be built in this space that just isn't being served by the traditional financial sector. Now, a lot of this stuff in the previous cycle we've looked at and gone, well, that was a little bit stupid. But there's some amazing innovations that have happened as well. If you look at what's happened with Uni Swap is already doing more volume than Coinbase is. And like, when you start applying that to traditional assets, if you look at Aave and what it's doing for the ability to do collateralized lending, and when you start applying that to traditional assets, you start to see how much this kernel could potentially grow into. Now, the reason that we think this is the future is because DeFi is finance built for the internet age. Like, if you think about your Web 2 experience, everything in Web 2, mostly speaking, is an incredibly intuitive, easy experience that automatically, instantly gets you what you want, right? And that's not true of finance, but DeFi is finance built for the internet age. It is the next evolution of technology, where internet was for information and decentralized finance is for money. And so if you look at this, there's like, this statement feels weird sometimes. Like, DeFi can do everything traditional finance can do today, faster, cheaper, and more efficiently. And a lot of people would say, well, Ethereum isn't faster or cheaper or more efficient. And I think that the important word here is can. Like, if you looked at the early days of the internet, like, people would be like, the internet will be able to do everything that you can do in the physical world faster, cheaper, and more efficiently. You'll be able to send things more easily. You'll be able to chat to people more easily. You'll be able to buy things more easily. But in the early days of IRC and the internet, you'd be like, yeah, no, you can't. It's just a bunch of geeks like sitting in a room together, looking at each other and going, isn't this cool? And that's kind of what DeFi is today. But like, it is the kernel of that possibility that drives us towards building that faster, cheaper, and more efficient world. And when it does, you know, I do believe that billions of people will be better off. I think that, you know, the global financial system, we'll talk about this in a sec, but the global financial system is $400 trillion, and that's only with like 30% of the global population actually a stakeholder within it. Like, what happens when we properly open that up? So, like, cool, right, great, big vision stuff, but how are we actually going to make sure that this happens? And it's an interesting one. Like, for a public ledger like Radix, our mission is actually about empowerment, right? Our mission is to give builders everything they need to obsolete traditional finance. We understand that we can't do that on our own. Like, we understand that our job is to create amazing tools so that other people can be successful on top of our platform, so that other people can build the next Google, the next Facebook, the next massive companies that will emerge from this technology opportunity. And that our job is to create an infrastructure that can be relied on, that can be used really easily, and that can make sure that other people are successful using it. So our mission is to empower you, the people who are looking to build in this space for the first time. And so, like, a lot of people say, but, you know, the DeFi sector is so huge, and, like, crypto's, like, grown so big, and, like, isn't it late to the game? And it's like, you know, when I got into crypto in 2015, there was this game that everyone used to play, which was like, what year of the internet are we in? And like by 2017, people were like, oh, we're in 1997. And I'm like, that's bullshit. Like, we are so early. Like, if you look at it, like, DeFi today is $100 billion, right? That sounds like a big number. But if you put it in context, if you 100x that from today, you're going to be at $1 trillion. That sounds like a huge number, but then if you look at what the global financial system is, you start to understand quite how far we have to go in terms of the available assets that you can build financial applications around. And you go, okay, well, actually, you start to see just how much value and money there is in the world and how big the opportunity is, but just like how of an invisible dot on a dot we are right now. And this sort of goes down to one of the things that we see as the biggest problem in the space. Like, in the last 2 years, capital in DeFi space is 220x'd. So it's not actually like, it's now at $100 billion. We're a little bit down from the last time I did this slide. But like, in 2 years, it went from $1 billion to $220 billion. That's an insane amount, especially when people are like, oh, you know, scalability is the biggest problem. People can't get into the space. It's like, no, like, people are putting huge amounts of money into the space. However, developers have only 2x'd. There's only 19,000 full-time DeFi developers, which is kind of insane when you think about like how many JavaScript developers there are or how many C++ developers there are. Like, it's grown so slowly, considering the fact that it's not like crypto hasn't been in the news. It's not like Web3 hasn't been in the news. You go and talk to someone and say, have you heard about Bitcoin? Or have you heard about, you know, Bored Apes? And like, everyone in the tech space has heard about these things. So why aren't there more people coming in? And that actually means, like, this is my favorite statistic, is like at the peak of DeFi, one developer was worth $11.5 million in total value locked. So if you took 220 billion, you divide it by 19,000, that's how valuable a developer was in the space. And like, you know, that's a little down now, but like, it still goes to show how big that constraint is, like how hard it is to find great talent in the market because of how hard it is to build using the tools that are available. And so this is what Radix is all about. It's about going, how do you create better tooling to make it easier for more talent to come into the industry? Because if that's what we can do with 19,000 developers, imagine what we can do with 1 million. Imagine, and it's not just the technical know-how, it is the new ideas people bring into the space. So I'm going to tell you a quick story. Hands up who knows who Hayden Adams is. Interesting. Hands up who knows what Uni Swap is. Yeah, okay, cool. So like, Hayden Adams is the founder of Uni Swap, and he's got a really interesting story. On July 16th, 2019, he was laid off from his job as a mechanical engineer at Siemens. And he was, you know, understandably a bit upset, just left university, got a job, got laid off, and was like, okay, what am I going to do next? And so July to October, he decided to take some time to start to learn Solidity. Now, by his own admission, was not a programmer, hadn't really programmed at all. This was the first time he ever touched code to actually learn it properly. So he started to learn Solidity, and then the other thing that he did is he spent a lot of time in the Ethereum ecosystem. He spent talking to developers in the space, hanging out on forums, like getting inspiration. He wasn't there to try and build something. He was just there to learn. But by the time he got to October, he thought of something that he thought he could build. There's this idea called Uni Swap. So he built a proof of concept. So in 2 months, October to November, from idea to proof of concept, And this is what Uni Swap V1 looked like. I actually remember this. This was like, I was like, they have a unicorn? So like, that was cool. And then this is kind of the insane thing. And like, this is like, it took him another year to make it production ready. And if anyone's looked at Uniswap, it is not that many lines of code. And this is another reason that we built Scripto. This is another reason that this is the #1 problem that we found when we were talking to DeFi developers. We've probably interviewed over 1,000 DeFi developers now in the last 3 years. And the #1 problem that comes back is like, it isn't building the functionality that's hard, it's making the thing that you've built secure that takes all of the time. And so anyone who's actually tried to build a production DeFi app will completely understand that. 2 months to build the idea, and then a year to harden it to the point where it can actually take money. That's insane. That's the reason that you see so few developers building in Web3 today, because people go, oh, I've got an idea, and then they go, oh, no, this is really hard. So it went live in November 2018 with $34,000 of liquidity. A year later, it was at $20 million of liquidity, 588x. Another year later, it was $3 billion of liquidity, 150x. And another year later, it was at $10 billion of liquidity. So, like, what are the lessons to take away from this? What am I trying to say? The first is, Scripto is better than Solidity, obviously. No, the lessons I'm trying to take away from this is like, look, there's so much green space here. There's so much opportunity that is like low-hanging fruit in terms of functionality, in terms of ideas. Simple ideas go a hugely long way. And that someone with no coding experience, literally had never developed before until that point, could build something incredible, right? And that's just one idea in a universe of ideas that are available to take. And so if you're sitting there and going, you know, like, that's fine, but like, I've never felt like I could build something myself. Like, I don't feel like I'm sufficiently competent to do that. I'm here to tell you, like, it doesn't take that much time because there's so much opportunity that's so easy, within such easy reach. All you need to do, spend some time learning and spend some time in the communities, and inspiration will come. The second is getting started by learning is the first step. Like, Hayden didn't come in, you know, from his, getting laid off as a mechanical engineer going, oh, I'm going to build Uniswap. He was like, no, I need to learn something new. So he spent time hanging out, and then over time, when he got to understand what the primitives were and how to build and what it really meant to build a DeFi application, he was like, oh, I see a gap. There's an opportunity here, but don't feel like the opportunity has to be there to start learning. You just start learning. That's the first and the most important step here. And the last thing is the founder of the first $10 billion app on Radix might be in this room. Like, I know that feels kind of weird to say, but like $10 billion feels like a lot of money in everything but finance. And just going back to how early we are versus how much value there is in this space, like, that's eminently possible and achievable for every single person here with just a little bit of time, application, learning, and willingness. So to end with a thought, the journey of 1,000 miles starts with the first step, and I hope that you guys feel that today is one of those first steps. Thank you.
Okay. So hopefully you're primed a little bit now. You're feeling, okay, there's an opportunity here that you want to take advantage of, and and this is, if there's nothing else you walk away from, I hope this is what anyone who's a developer, or even who is interested in starting to become a developer, takes away from this, is that there is an enormous opportunity here in this space. It is very, very early on, and it's a great time to jump in. I'm going to go a little bit deeper on kind of similar topics, but start getting in a little bit more into why Radix. A little bit more into like specifically what DeFi is about, what smart contracts about, why this stuff is so important. Then that'll lead into some of the developer discussion. So I want to talk about why DeFi is the future, and specifically We believe that DeFi is a future kind of on pause in a sense. I mean, Piers went through the fact that DeFi today is tiny compared to the overall global financial system. And it sort of begs the question, why is that? Why is it that it's not even a pixel on the chart right now compared to the full opportunity? If that opportunity is there, why aren't people rushing in and building stuff, and why isn't it growing at a much faster pace? To answer that question, I'm going to step back a little bit, and I'm going to do this. I'm not going to spend too much time on it. I don't want to turn this into a professor lecture, but I want to talk about the history of money and why finance is so important and why it is a $400 trillion market, what makes up that system, and when we're talking about replacing that system with something that we think is better, what does that actually mean? So in the beginning, there was money. Money was just cash. Money was, coins. It was things you had on hand, and it really was a financial technology. This was the first time that allowed us to move beyond just pure barter of things. You could give money to someone. You can conduct transactions sort of over time. But of course, it's very limited. If you think about all the people that participate in the medieval financial system, it was just person to person. If I could literally go up to you and hand you something, a bag of coins, all right, I'll take your ox and I can go do something with that. Obviously, this really limits the scope of what the financial system can do. So, people aren't stupid. They immediately started thinking about, well, what's a better way of handling this? If I've got a business, if I'm producing something, I'm a farmer or whatever, there has to be something else here that helps me expand what I want to do in the world. And you can kind of categorize this. It expands quite a bit beyond this, but if you think about the things that commerce and what merchants wanted to have access to, they wanted access to things like settlement and lending and exchange and investment. All those things add these new tools to their financial toolkit. A settlement system would allow you to essentially conduct transactions over a larger distance. I could say there's someone in the next town over that I could conduct a transaction with, therefore the scope of my business can expand. Lending means that I've got more of I can shift my business over time. I can secure capital that I can then use to expand my business more quickly than I could with just cash on hand that I'm reinvesting. Very, very powerful for increasing the scope of business. Exchange allows you to have multiple economies that connect to each other. You don't have these very insular single economies where everyone is locked within that. You can now start, it's funny to think about it, but in the Renaissance, we literally had a global economy. We think of this as a modern thing, but you'd be surprised what the scope of finance was at this point. You had people that were trading over enormous distances, and it was all negotiated by exchange systems and lending systems. And then investment, of course. Investment is something that if I have capital of my own, I want to be able to put that capital to work in some way. I don't just want to have a bunch of coins sitting on my mattress someplace. I want to be able to put that to work. And when I put to work, this then allows others to expand their businesses more quickly and to expand the scope of finance once again, and business. So how do you create these things? And imagine sort of the medieval world transitioning into the Renaissance world. How do you start offering these kinds of things that commerce is asking for? Give us some way of doing this. And the solution, of course, was the banking system. And the banking system, as we have it today, is essentially the same basic pattern that was established in the Renaissance. You had a set of institutions that struck a different bargain. Rather than everyone just having cash on hand and everything being essentially P2P, you now had a system where the bargain is, well, look, we're in these institutions, we're going to build big buildings that are very safe. You can trust your money to these institutions. And once we do that, those institutions had relations between them, and that allowed you to do things that individuals couldn't just do on cash. It was a hugely powerful technological shift, if you want to think about it that way. So now, settlement and lending and exchange and investment all became possible because banks made it possible. It abstracted the system up one level, and they could do things because essentially they had the economies of scale that individuals couldn't possibly do. And this unlocked an explosion of commerce and everything else. This was a major part of why the Renaissance was the Renaissance. And it was all based on this notion that this change of the bargain required that system be safe. Individuals weren't going to trust their capital to these institutions unless they could be like, yes, I can get my money back later from that. No one's going to be able to steal that money. This was the fundamental bargain of this new system. However, we're here in the internet age. And as Piers alluded to, the internet age we have a different set of expectations for things. And we have those expectations because the internet reestablished a different bargain in the communications realm. What it said was, if we all participate in an open network together, and that open network being the internet to begin with, you can communicate with each other in a way that is more competitive, more convenient, more inclusive, and more cheap. There was if you think about communications, there was a similar system in place as there was with the banking system. You had AT&T, and you had huge telco companies that essentially were these large institutions that gave us the economies of scale that allowed us to communicate globally, but within the limitations of what those institutions could do. The internet showed us that an open network is immensely powerful. If you have an open neutral network, it allows much more innovation that allows you to get these better attributes, and it's hard to deny that now global communications is much more competitive, much more convenient, inclusive, and cheap than it was back in the 80s and early 90s. So we have these expectations. It's like, oh yeah, open networks deliver these things. I should be able to, if I want to talk to someone on the other side of the planet, there should be 1,000 different options on the App Store that I can use that allow me to communicate different ways. This is just our base assumption now. But if we compare that with finance, things feel a little bit out of step. And so the DeFi vision is basically, well, we would just want to apply the same model. Is there a next layer that we can apply to the internet that allows us to do the same things with finance that we're already used to doing with communication? And this is where you'll hear a lot of people talk about the Web 1, 2, and 3 transition. Kind of the cliche now is that Web 1.0 is consume, Web 2.0 was well, I guess the way they like to put it is read, write, and own. But the first iteration of the internet allowed you to read things that other people had produced. Web 2.0 is it became interactive. We were going both ways. We were pushing things both ways. Web 3.0 is now we bring an ownership layer to that system. So this is where Web 3 and DeFi are essentially, in my opinion, terms for the same thing. How do we do this? How do we establish notions of ownership and finance in the internet world? And what it requires is reestablishing a new bargain. It's not, you know, I'm not a big ideologue about banks are evil, and, you know, like, I mean, there certainly are problems, and I think a lot of those problems have to do with transparency and things like this. But, you know, it's essentially the best we've been able to do for centuries is the fact that we need banks in order to do these things, or else the global economy doesn't function. The issue is, like, you really can't do any better with that structure. You need to go to a different kind of system, and the way you do that is a different bargain. So like the internet, the new bargain is that we need to have each individual connected to an open network in the way that they directly keep control of their own assets, their own ownership. You remove this need to trust an intermediary party. It's not the fact that just disintermediation in itself is an ideal that we need. It's the fact that you simply can't do any better unless you disintermediate. Because once you have that, once you have an open network where everyone is directly controlling their own assets on the network, now we have the ability of having that open network run thousands of different applications that all have equal access to everyone's finances, everyone's money, their ownership, their identity, in the same way that you can have 1,000 different applications that are competing for your business in communication across the world. And what this means, and the belief I think it's behind a lot of people that are in crypto and in DeFi and Web3 today, is that that system inherently is going to build a financial system that's more competitive, convenient, inclusive, and cheap. And it has to be in a way, I put this one in green because it still must be just as safe as what people are used to with banks today. We can't go backwards on that bargain that we're used to. So again, as Piers put it, we're in the early days of this. DeFi today is a little bit crazy. It's the very, very early stages of this. And so, you know, we can, well, I'll actually get back to this a little bit, but you know, you can certainly point out places where DeFi does not meet this vision, but our belief is that structurally speaking, a system that works in this way, long-term, inevitably is going to have these attributes once we have a system that's good enough. So I want to zoom in on that chart a little bit. I'm going to start getting a little bit more into the developer side and a little bit more into the technology side, because I want to explain how this system actually works. Like when we say, great, we've got this open network where everyone controls everything, that sounds wonderful, but like, what do I actually mean about that? What is that concretely? So let me zoom in on that chart a little bit. So you have this person at the edge of this network, and they have some sort of, you know, position on that network, some sort of direct ownership on that. What that means is, well, I guess what I'll say is these decentralized networks, DeFi networks, have 4 superpowers. And Ethereum was the first one that really exposed these superpowers of what you could do. Bitcoin essentially did one of these, and then Ethereum added on 3 more. The first one in superpower is the idea of tokenized assets. Now again, Bitcoin was essentially the first one. It was the first purely digital asset. It was the fact that I can directly have an asset of value on this network, and I can freely interchange it with anyone on that network. Ethereum then opened up the idea that we can have many other types of asset classes. We can tokenize essentially anything, and this goes anything from digital versions of fiat currencies like the dollar, cryptocurrencies of various types, but it even gets into things like tokenized assets from games in the metaverse. You can have equipment and user identities, you can have contracts, you can have NFTs. All of these things are just tokenized assets of various classes. And again, we're just in the early stages of this. And to me, one of the reasons why NFTs are exciting is it's people experimenting with this idea of like, hey, oh my God, for the first time we actually can have digital transfer of ownership of pieces of art. We didn't think that was possible because in the normal web, it's like, well, anybody can copy this. How do you know who really owns it? NFTs give you that. You can have this link between a piece of art and a singular notion of ownership, which people can transact. So we're just starting to experiment. We're just starting this process of progressively digitizing ownership of everything in the world. And this is very, very powerful. Second superpower is this, Dapps, smart contracts. What this means is once you have those assets, once I can go to this network and I can own things directly on that network in a very direct way, I need to be able to do stuff with this. I want to have essentially programs running on that same network that can interact with those assets. Because if all I can do is say like, great, I've got this NFT or I've got this token and I can give it to you, okay, that's pretty interesting. But the financial system does a lot more than that. It needs to do lending and settlement and all these sorts of things. And you even get into things that maybe don't feel like finance, but I think actually are. If you look at in-game economies, for example, in the gaming sector, if you go to any online game, there are exchanges that are part of the game. They're essentially like lending actually kind of comes into play in some of these things. Like these are toy versions of everything we get in sort of the mature adult financial system. So we need functionality, we need smart contracts, and that's what it is. It's basically just programs that are running on the same network, the same neutral open network. It's not an additional system that's connecting to it that can directly interact with all of the assets that are on that network. Now this is very powerful. With that, we can start to build models of things that happen in the traditional financial system. So I'll give you a very simple example. So, if you've ever, traveled internationally and at the airport, you'll see a million of these currency exchange things. You go up there, you hand them, all right, here's some dollars, I'm going to need some euros back. There's a current exchange rate that they're willing to offer you. They take a little bit of a cut off of that for providing the service. Great. That was a financial transaction. And it was actually, if you look at kind of in the medieval sense, this is a very high-power financial transaction. You're moving between different economies and so forth, but we've made this very, very convenient. So how do you model that in the open network pattern with a smart contract? Well, once you've digitized those assets and once you have smart contract functionality, you can build a model of something like this. And it might look something kind of like this. You might have, you can imagine that the person that wants to do a trade has an account. That account has, there's some sort of, they've got a key that allows them to get into that account. And they can send some assets from that account into a little piece of logic that represents the exchange. That exchange goes, oh, okay, I can see you gave me $10. The current exchange rate against the euro is 1.39. Okay, I'm going to send you some other tokens back to your account. Very straightforward. You can all do this because you have the assets and the logic running on the same network where we can trust that that result is going to be correct every time. So this alone is very powerful. However, we needed an additional pair of superpowers to really get to something that can replace the financial system. So the third superpower is composability. Composability says that you don't just want to have one application that you're interacting with at one time, because that's a very simple system. Great, I can do an exchange, or I can take a loan, or any of these sorts of things. What I need to be able to do is have layers of abstraction behind this, because this is, again, how the financial system works today. If you go to your bank and you have a financial product that they offer you, sitting behind that are layers of systems, relationships to other banks, derivatives and options and all these sorts of things that they're taking advantage of that produce returns. Well, we used to get returns on our savings accounts. We don't anymore. But all these things are built on layers of functionality that all need to connect together. In the financial system today, these are the relationships between those banking institutions. They have their own proprietary systems that allow them to work together to produce these sorts of things. So what we need in the DeFi system is on that network, you need to have applications that can directly connect to each other. So if I'm building an application that users are interacting with, maybe sitting behind that, I've got 5 other applications that are providing bits of functionality and financial functionality that I need to produce an interesting result. So this is composability. And the last superpower is two-sided markets. And this is one that's a little bit easy to overlook, but it's incredibly important to understand, particularly if you're interested in getting into building DeFi applications. It's not just the fact that you can have applications that connect to each other, and each application has sort of like a single set of users associated with it. Basically, all of finance, and again, when I say finance, I don't just mean kind of boring banking sort of systems. I mean gaming economies and all these sorts of things. Is that there are almost always two-sided markets involved. There's always a maker and a taker. There's always a buyer and a seller. There's always 2 people on the other side of it. And typically in the financial system as we have it today, it's a very one-sided system. Basically, the bank is one side of that, and you, the user, are the other side of it. You need to get something from them, and they have all the relationships and the capital and everything they need to provide that. So if you look at something like the currency exchange thing that I mentioned here, you would imagine like, okay, I can imagine like a bank would have a lot of capital that they're introducing into that system that allows them to produce these currency exchange trades. But wouldn't it be great if we didn't have to have a single company that had to gather all that capital together? All of us have a little bit of capital. All of us are saving a little bit here and there. Wouldn't it be great if you could have a two-sided market where not only is the person wanting to do the trade able to do so individually, but people that say like, yeah, I've got some capital, I'm willing to put that into a trade system if I get a little bit of a cut on the return, if I get some benefit for locking that money up on the other side of the market. Now you've got an individual, democratized, two-sided market that enables anything that the financial system can do, but at a much more grassroots level, a much more individual level, a level where every one of us has individual ownership and participation in the system. We don't have to go through large intermediaries to be able to gather capital, produce functionality. And those four superpowers together are what allow us to build a system where you can have a neutral network that can truly, in the end, replace the financial system. So Ethereum does this today. This is the Ethereum proved that if you have these four things, you can start to chip away at it. It's kind of, you know, I mean, as Piers is pointing out, there's quite a bit of money in DeFi today, but compared to the overall thing, it's tiny. But in microcosm, it's proving its existence proof to me. This is one of the cool things about Ethereum, is it proved to the world that, yes, you can in fact do these things. You can have digital ownership. You can have these two-sided marketplaces in prototype form. Even if it's slow, even if it's a little bit expensive, it's possible now. And what that means is, again, everything that we're used to now becomes possible. You can have this world of digitized assets that can interact with a world of applications, everything from what we typically think of as finance all the way to notions of the metaverse, of sort of economies that need to connect to each other. All these sorts of things become possible on these open networks that have smart contract capability. So the question then is, why isn't it exploding already? If we already have a network that has these four superpowers, once again, is why is it so tiny? And what it comes back to is, well, what is it that we really wanted out of that system? Beyond just an existence proof, what should this tangibly give individual people? Everybody in the world should be getting a real benefit out of the system. And what they should be getting is a system that's competitive, convenient, inclusive, cheap, and safe. The problem is that DeFi, the platforms that have these superpowers today, aren't doing it in a way that actually provides those benefits in most cases. So if you look at Ethereum, and I kind of hesitate to be too hard on Ethereum because it really was a revolutionary platform, but it was, you know, the 1.0 platform. If you look at it as of today, it isn't particularly competitive because the competition for talent is so high. This is as Piers was saying. Right now, even if I've got a great idea in Ethereum, I'm limited in how quickly I can roll that out, just literally because I can't get the developer talent that I need to be able to build it quickly. And what this means is that there's a relatively small number of applications because they're all competing for the same small talent pool. It's not particularly convenient. Anyone who's used DeFi today, you've gotten MetaMask and you've connected these sorts of things, it's really hard to argue that DeFi is convenient right now. It's very, very technical. You have to sort of understand how these mechanisms work. You have to understand how private key pairs work and seed phrases and all these sorts of things. So this needs to be improved. It's not particularly inclusive or cheap. Both of those kind of go together. If you've traded on Ethereum, you've noticed that transactions are very, very expensive. And what that means is, it means that overall it means that dealing with the network is expensive. It's not cheap. And the other thing is, if it costs $50 for you to do a trade on this open network, well, you've now excluded a large number of people in the population that $50 per trade doesn't make sense to them. Sure, if you're trading $1 million at a time, who cares? It's in the noise. If you want to trade, $1's worth of something to get a really cool NFT that your friend made, you're never going to use that network for that. And safety is the other problem. Again, if you've tracked DeFi as is today, it's, for the most part, sadly, but just about every week we see another exploit of some smart contract on Ethereum today. And I'm going to get into the reasons for that. Again, it's not it's not really a flaw. Well, I'll get to it. So this is the problem, is that even though the potential is there needs to be a better solution to actually deliver that potential. And that, again, of course, is where Radix comes in. So our whole mission is to give builders everything they need to truly obsolete traditional finance. I won't go into the sales pitch because I want to kind of get into how we do that. To take that mission statement a little bit further, what we want to replace that system with is thousands of DeFi apps and assets, and that's where we're doing this thing. We're trying to bring together developers that want to participate in this. Our job is to empower people in this room to make this possible, to give you all the stuff that you need so that the platform gets out of your way, the developer tools get out of your way, and you know that if you have a great idea, you can actually bring it to the market, you can actually start competing with the traditional financial system, and you can start progressively remaking how the world works. And that's how you get from a financial system, as it's been for the last 300 years or so, to a DeFi-based system that's built for the next 100 years or more. So I'm going to go down one level further. How do we do that? I'm going to talk a little bit about Radix. So Radix has been in R&D mode for many, many years now, and we launched our public platform in July. We've got a roadmap that I'm going to go into. We've put an enormous amount of R&D into, I'd say, 2 major sections of our technology approach that's all designed to address this particular problem that we're seeing right now. So the one major bundle of technology is the fact that we need a platform that is built for builders. We need something that's not just sort of like, hey, here's a platform, it's capable of doing these things, you figure out how to do it. Like, we're not, it's up to you once the basic capabilities there. We need something where if you have a great idea, you actually have the ability of practically deploying that. And our solution to that is Scripto and the Radix Engine, which we're going to go into quite a bit today. Our tagline for this is it's an asset-oriented form of smart contract, which is a very, very different way of thinking about building smart contract functionality that we're going to be spending quite a lot of time on today. And the goal of that ultimately is that we need those technologies to deliver the fastest possible path from idea to production DeFi dApp. The other major edge of technology that we've researched is that we need a platform that's built for scale. And this is the one that's, if you're in the space, this is the one you're a little bit more familiar with. We kind of feel like most platforms are ignoring the builder side of it. They're very focused on the scalability side. But even then, we feel that they aren't focused on thinking about the scalability problem in the right terms. The issue here is that it's not just about like, all right, we've got to get from 15 TPS to 100 TPS to 1,000 TPS. TPS is transactions per second for people who don't know. So, people tend to think of like, well, the Visa system does 3,000 transactions a second. All right, we need a blockchain that can get up to 3,000 transactions a second. It's the wrong way of looking at the problem. If you look at the global financial system, $400 trillion of value, people all over the world interacting with you need a system that can't just sort of like, all right, we continue to raise the bar on transactions a second. We need a system where my transaction with you has nothing to do with transactions between you two on the far side of the room. There's no reason why those transactions need to know about each other, and so they shouldn't be going through the same pipeline. It's basically the architecture needs to look more like the internet itself. The internet is designed, the protocol, so that individual packets of traffic can move around here and it doesn't interfere. We're not going through a single network pipeline that then is fanning it back out to everyone. It's a network that allows independent things to remain independent. We need the same thing for finance. We need the ability of having unlimited parallelization, if you want to use the technical term, so that individual transactions can be conducted, which essentially means that there needs to be no limit to throughput. There needs to be a network that's configured so that as there is more demand for that network, it automatically incentivizes more people to contribute more to that network and make more transactions possible, to add more parallelization. So without going into the technical details, and I can answer questions about this if those are interested, we have a unique consensus approach that we call Cerberus, which is a braided cross-shard consensus mechanism that's very jargony. The reason it's important in the end is unlimited dApp throughput and low fees forever, if you want to cut to the chase. This is something that's on our roadmap, that we have a fairly deeply different approach to this problem that we think no one else is looking at. Okay. Last thing I want to talk about, and then we're going to go to some Q&A, and then we're going to start getting into more of the Scripto tech stuff. I want to talk about flash mobs and movements, because this is also a really important thing. It's not all technology. What we're talking about, if we're talking about figuring out a way of building a better financial system together and really thinking meaningfully about what that means, not just making it sort of like, yeah, we're going to change the world because everyone's trying to change the world, right? Like, what does that actually mean? Like, how do you go from the beginnings of an idea to something that really has that potential? And my answer to that is it has to be a movement. It can't be a flash mob. And what I feel is totally setting aside the technology, the different technological approaches in the blockchain space today. The approach that everyone seems to be taking is to build a flash mob approach. It's sort of like, right, we do a great big ICO, we get a whole bunch of money, and then we just start throwing that money at developers. Come to our platform, and we're gonna get developer momentum. Because it's a very short way, it's a very short path to looking like you're making progress. You just say like, all right, we're gonna pay for activity on our network. Oh, look, we've got all these developers that are building on the network, and then the money runs out, and then they all go someplace else. They try to find the next bag of money. We need to build as a movement. And movements are things that are, the reason why they build is because everybody in that crowd believes in something. You didn't pay for them to be there. They're there because they chose to be there, because a friend of them told them, hey, here's this great idea that I heard that really changed my thinking about everything. Let me tell you about it. And if you agree with me, join me. Let's go work on it together. That's how movements get built. And movements have to be built around something fundamentally real. It has to be built around a real solution to a problem, or an actual change in mindset that you hadn't thought about before. And so our approach to technology has always been about how do we provide the technological tools that on their own merits, people pick these tools up and go, oh yeah, I can build something I couldn't build before this. This is amazing. And we're just starting to build this. And actually we've got some people in the audience here that are part of our current community that have embraced that vision, and it's great. They've been going off and doing things on their own that are greater than we could have even thought about. But we're just at the beginning. And so what I'd like to say is, you people are here very early. The potential developers in this room can be part of a movement. I hope you agree with this. What we want to do is try to convince you that we have an approach that we think can build something like this. If you agree, we want you to join the journey with us, and we want to help you. We want to help you figure out how to expand this even further and take it to the point where all of us are working together to make this change in the world. So with that, we'll go to some Q&A. Excuse me. So I think I can pull up the Slido thing on here, right? Yeah. So let's see if people have some questions. What issues about production readiness are specific to DeFi as opposed to, say, consumer APAs or data ETL pipelines? Yeah, that's an interesting point. Yeah, it is, because it's a different. I'm hoping I'm addressing the question the way you're thinking about it. So if production readiness in a traditional, like a Web 2 sense is you're building fundamentally a closed system, and you have a set of APIs that provide an interface into this closed system. So in some way, like, you have full control of kind of what happens within your walled garden. And so, your customer is sort of internal in a way. Like, you're trying to build a system that's robust enough that everyone in the organization can rely on it, and it's all functioning such that the API requests are being served in a particular way. It's kind of a similar system in Web3 and DeFi, except that you're kind of operating out in the open. And this is where the bar is much higher. This is part of why you see a lot of exploits in that, is that you're essentially running you're running the programmatic financial logic on the open network, and fairly fundamentally it needs to be open source. This is actually, I think, a feature of the system, is that, I alluded to this earlier, my opinion is one of the major problems with the banking system today, aside from anything else, is just purely lack of transparency. If you look at something like the 2008 crash, the issue wasn't it wasn't structural in the way that sort of the derivatives and things that were being built were fundamentally problematic. It was just the fact that no one knew what was going on. No one knew that, oh, this thing represented these asset classes that were actually valueless, but they were being overvalued and that sort of thing. The transparency is what caused the issue. So in this case, we have a very, very transparent system, but the flip side of that is the fact that anyone can see your logic, and so people are really good about finding the edge cases. They go, oh, actually, well, if I can manipulate this oracle, then I can do this, and then I can run off with $1 million. And this gets very much to what we're doing with Scripto, is that this is why we feel like the smart contract approaches just aren't good enough, because they're not designed to limit those edge cases. They're not designed to build an open piece of logic where it's very, very clear how it's going to behave, and you're not going to have these sorts of edge cases. So that, to me, is the difference in the production readiness. Like, right now, if you're building with Solidity, and I don't know how many people in the audience have experience with Solidity, you can write your first piece of Solidity code in an afternoon. It's built based on JavaScript. You can build a little prototype, and it's really cool. The issue is, if you want to have a deployment-ready Solidity application, you really have to go deep on sort of the common practices and the patterns of using that. So it's like, well, okay, if you're interacting with an ERC20 contract in this way, you need to do this check, because that contract might actually not be trustable to do this thing right, and you have to learn all these patterns to sort of cover over these issues to make sure you don't, and ultimately have a system that's exploitable. So that path to getting from idea to that level of production readiness, where you can put this out in the world and be confident it's not going to be hacked next week, that bar is extremely high today. It takes people multiple years to get to that level of expertise so they can reliably do that, which again is part of the reason for the shortage of talent in the space. Is Radix compatible with F layer 2s? It is not, and I'll get into that very specifically. that compatibility comes fundamentally from EVM compatibility, their virtual machine, which is sort of it's basically the computer that runs on the Ethereum network. We have designed our computer in a very different way for some very good reasons that I'll go into, but it does break compatibility, and that's by choice. What's the process of becoming a Scripto developer? Well, there is no process. If you're asking the question, you're already a Scripto developer, just about. It's pretty straightforward. You know, I mean, basically this session, if you're watching on, I don't know if this person is in the room or calling in, but this session is a great place to start. Where this is exactly what we're going to do in the afternoon. Is we're going to start from zero. We're going to show you how you write your first piece of Scripto code, how you issue a token, how you build a decentralized exchange. We're going to go through that. We've got documentation on our website. So if you go to developers.radixdlt.com, or if you just go to radixdlt.com, you'll see our developers page. And we've got lots of documentation, we've got lots of example code. Dig into it. What we're finding is that even people that have virtually no programming experience are able to find a toehold and get started. Who is Radix's biggest competitor and why is Radix different? Oh, that's a deep one. Biggest competitor is a hard one. I mean, Ethereum is clearly the dominant player in DeFi today in terms of just momentum behind the platform. It's absolutely Ethereum, no question about it. So in some sense, I sort of consider them our biggest competitor. If I want to be cheeky, you know, my biggest competitor is the banking system. Like you know, that's kind of how we approach it. I mean, it sounds cheesy, but honestly, this is how we approach our technology roadmap. It's not so much like, hey, what do we need to do to sort of like minimally beat Ethereum on all these checkboxes? We're kind of going, we need to build something where people, when people build an application on the platform, it actually is competitive with the financial system. It's not sort of like, well, you can do this, but there are all these downsides to it. So we really do benchmark against how things are done in the real world. You know, there's some other networks. I mean, Solana has some interesting approaches to scalability, and Avalanche does as well. There are a number of competitors in the space, but I mean, I'd say the fundamental difference on that level is just we have fairly deeply architected the stack with that long-term goal in mind. Everything, you know, we don't use EVM, we use our own virtual machine, our own programming language, our own, and our own consensus mechanism, top to bottom, and we had to do that in order to build something that was good enough. So it's, you know, pretty much everything about what we're doing is somewhat different. What's the difference between Solidity and Scripto in a few words? I'm going to do it in more than a few words, just the next conference, in the next talk. So I'm going to put that one off a little bit. I'll tell you very much what the difference is on that. How is the Radix organization structured? Is it a DAO, private company, et cetera? Good question. Yeah. So Radix is the public network, and you see on these slides, you know, I work for RDX Works, and the team here works for RDX Works. We're the original creators of the network protocol. Back in July of last year, we published the first version of the Radix protocol, and the network was immediately decentralized. Like, we had a community of people that showed up, decided to run that protocol, started operating the network, and from day one, this was not a network that we were operating. So there's a distinct difference. You know, Radix as such, Radix is the network. Radix is the community. Radix is the thing that's out there that basically our community owns and operates. And RDX Works, the company, we're a private company, but basically we exist by, you know, definition of the company. Our whole focus is making that network successful, making sure that developers using that network are successful. And so we're putting all our resources into that. But there's a very strict separation. You know, we don't own the network, we don't run it. It's a community effort. Is the goal for Scripto to solve challenges in secure and fast deployment of DeFi-based applications, or to facilitate easier abstractions and creating new things? Both, absolutely both. I think you'll see that in the rest of the day. It's, you know, I think it's important that it is both, and I think you'll see this. I think, you know, it's easy to think that there's a trade-off between saying, well, we're going to make it really fast and easy to do these particular things, but then there are all these other things that you just can't do. It's sort of like the, you know, the play school approach. It's like, all right, you can build a few things, but if you want to do something that's custom, you can't do that. That's not the approach we're taking, and I think you'll see that the idea here is that what we're trying to do is build the right abstractions into our development stack so that you have the ability of achieving fast and secure deployment without giving up the flexibility to build what it is that you really want to do. And hopefully you'll see that as we go through it in more detail. What's the current size in terms of number of devs or Dapps of Radix versus Ethereum? I'm also going to put this one off to the next talk because I'm going to be talking about our roadmap, and you'll get a bigger picture of where we are on that roadmap. For us, it's more about developer community right now. To sort of cut to the chase, we have the public network as it is right now has no smart contract capability. This is sort of V1 of the network. V2 of the network is coming. This is what we're here talking about, is what's going to be possible at V2. You can start building with the tools that are going to move on to the public network at V2, but basically we're trying to get developers involved right now to inform that development to make sure that when we do put it on the public network, everyone's behind it. They go, yep, that's the solution we actually needed, and we're ready to go to deploy things. We're not deploying it to the public network as an experiment, but like, hey, we think this is what you want. And then we find out, oh, actually, we have to change a bunch of things, and now it's on a public network, and it's difficult to do. So I'll go into the roadmap in the next section. Okay, well, I think I got us through our questions. We're going to take a short break now. We can do, have some conversation, get some refreshments. When we come back, the next section, I'm going to start up again, and we're going to start getting into Scripto itself. So first thing I'm going to get into is talking about how Solidity is a different approach to building smart contract functionality, kind of like the pieces that we offer, which I think is a really, it's really useful to have that in mind before we get into the code. So the next sections after that is Clement, our developer liaison, is going to come through and start actually leading you through what Scripto code looks like. So we'll take a short break and we'll come back soon. Thanks. Okay, we're going to get started. If everyone wants to filter back to their seats. So we're about to start the next session. The next session is going to be, we're going to start getting a little bit more into the technology. We're going to start talking a little bit about Scripto and what DeFi on Scripto means. Just so you're planning ahead, we're going to do this section. This is going to be the first point where we get our laptops out. For those of you that want to follow along, and then we had some instructions for people that were coming who wanted to follow on their laptops. We're going to start doing that in this section. After we get through this workshop, we're going to break for lunch, and then we're going to come back for some additional workshops. I'll leave this up here. Before I get started, once again, I'll put this up again. As you're going along with this section, if you start having technical questions, however deep you want to go about Scripto and how some of these things that we're going to be talking about work, please do use the Slido link and get the question in there, and we'll make sure to get those answered at the Q&A at the end of this section. So with that, we will jump in. So before I turn it over to Clement's going to be running our coding sessions. I wanted to give a little bit of an introduction to Scripto. And this gets into some of the questions that people had about how does this compare to Solidity, how does Radix Engine compare to EVM, some of those things, and gives you an idea of what we call the asset-oriented way of going about building smart contracts. It is asset-oriented. It's a term that we've sort of coined. You'll get an idea what that means, but it's a pretty different way of thinking about how you formulate building smart contract functionality. It's quite a bit different than the Ethereum model, and the Ethereum model is essentially what every other blockchain is using today. What we've been finding with our community is that once you internalize this different way of thinking, it really leads to much more simplification in the build process and a much more intuitive, safe result. So I want to kind of go through the concept at a high level, because this will give you some context as we start getting into the code. So what we're going to go through are these points. I'm going to start with the problem with smart contracts today. Like, if we're doing something very different, we need to justify it. So what is actually the problem today that we're trying to solve? Why do we think there's a different approach that's needed to smart contracts? And then we're going to start to get into Scripto and Radix Engine V2. Radix Engine being essentially our version of the EVM. It's our virtual machine. And when we get into that, the points I'm going to talk about are resources, components and blueprints, accounts and transactions, and then I'm going to close up by talking about the current tool chain and our development roadmap, so you have some context of where we are in the process. So let's start with the problem with smart contracts today. So this is going to be remedial for some of you that I know have some experience, but for those of you who are very new to smart contracts and the concept of it, I wanted to give you at least a beginning feeling of what a smart contract, how it works, and what it means. So essentially, you can think of a generic smart contract environment like this. You have a shared platform, so the gray box, imagine there's a shared computing environment, which is a network in this case. And on that network, you can have these modules of functionality, each one of those boxes being a smart contract. So we have, In a little way, I'm just old enough that this analogy makes sense to me. Maybe it doesn't for you, but in some ways it's a return from the mainframe era. It's the idea that we have a shared computing environment and individuals can sort of sign into that environment, they can deploy a piece of code, and they can run it all in this shared computing. So you can really think of, Ethereum likes talking about the world computer. It's a good metaphor. It's the idea that you have a network that operates as a single computing environment that lots of people can use. And so if you think about a very generic concept of a smart contract, it's really this thing that just has one function, which is computation. You can load code here, the network will run it for you, and it'll assure that that code is run correctly. This is sort of abstracting away all the consensus stuff and all that kind of stuff. As a developer, you kind of don't need to worry about that. Consensus is that's just there to make sure that the right thing happens, that you don't have incorrect transactions happen. So from the point of view of a developer, you can just think of this as a computing environment. However, it doesn't stop here. If this is all you had, you wouldn't actually have the system with the superpowers that I mentioned earlier. You wouldn't have a system where you could compose things together because you'd have these little individual applications that are running that wouldn't be able to talk to each other. It wouldn't be all that useful. So in reality, the Ethereum virtual machine adds an additional feature, which I call messaging. It's basically the idea is that when you deploy a piece of code, messages can be passed between those pieces of code in the form of method calls. And so now you get a system where okay, now not only is it just one place where lots of programs can run individually, now they can start working together in a coordinated fashion, which now allows you to, now you can build a smart contract that represents a token or a smart contract that represents an exchange or whatever it is, and all these things can start working together. So this is the basis of basically everything that's going on in the smart contract space today, is a shared computing environment where individual smart contracts can talk to each other. And of course, transactions are also, it's basically a way of messages coming in from the outside world. I can descend in this environment and pass a message to a smart contract and it runs off and does something. So this works. This is the pattern for today, but there are problems. So I'm going to go back to the example that I used in the previous slide deck of this exchange. And that exchange is basically, for those of you familiar, Uni Swap. Their core functionality conceptually looks like this. It's the idea that you have someone who wants to make a trade. They want to send some tokens into like a trade method on this smart contract. Then that does some computation, figures out how much tokens should come out the other side. It's got a couple of token pools. So these are actually user contributed pools of liquidity. So maybe you've got some USDC tokens and some ETH tokens or whatever it is. And then ultimately goes, oh, okay, I can see that I need to take so many B tokens out of my pool and send it back to the trader. Conceptually, it's super, super simple. There's nothing to this. You feel like this should be a trivial application for you to write. But as Piers was pointing out, the first person that solved this got an application that's worth billions right now. However, that application, as it's written today by the guy that Piers mentioned, actually looks more like that. It's really complicated. And the reason for that is, if I go back to this slide, I'm making a lot of assumptions in here. I'm saying like, well, I'm assuming that you can just send a token. And this contract has some pools that it holds these pools and it can send B token back. This is how we intuitively think it. But if you go back to this the idea of this shared computing environment, well, how do I express that in this language? And the answer is you have to do something like that. I have to have, for token A and token B, I need to have an individual smart contract that implements the idea of a token from scratch. And the way it does that is it has basically an internal list of token balances. It goes, okay, this user with this account address, they have 5 tokens, and this other guy has 20 tokens. And it keeps track of that. And when you want to interact with it, you tell that smart contract, you say, okay, I wish to transfer tokens, and it adjusts the balance inside that smart contract. So it works, but in some ways, it's kind of like the banking model. So you can kind of think of, you have these little individual banks and they're sending messages between each other, and there's no universal notion of assets across this. And this leads to a huge amount of complexity. Again, it's working today, but this in the end is the source of a lot of the exploits you see, because you can imagine how if you have a system where you're having to do these multiple coordinated messages and a lot of error checking to make sure that, for example, if I want my Uniswap contract to change a balance in 2 different ERC20 contracts, I have to verify that that actually happened correctly, because I don't know what the internal logic of those smart contracts actually looks like. It might look like a token from the outside, but it might actually be something that's behind the scenes doing something kind of funny to not do what I asked it to do. So I have to, in my own contract, I have to verify, I keep my own list of balances, I have to do about a bunch of this checking. You can imagine that in that sort of complicated system, a hacker comes in, sort of does some analysis and go, oh, okay, I can see that you missed one of your checks here, so I can inject a message in here that you weren't expecting, and then I can run off with some money. It's a very complicated system. In programming terms, it's difficult to reason about. It's difficult to build a mental model of what's going on, and so it's very easy to make mistakes, even for a very experienced programmer. And this is why it's a little bit cheesy, but one of the developers we talked to in the Solidity ecosystem said that, yeah, I'm spending about 10% of my time writing the part of this that I care about, and about 90% of my time writing all this checking and everything to make sure that there's no issue that I have to worry about. And this is a real problem. You're not going to get a revolution in finance if you're spending 90% of your time not building the thing you actually care about. So this is the problem that we're trying to solve, is there's something wrong with this model. We don't want to just take the EVM, drop that on top of Radix and say, great, this is good enough, and we're just going to focus on scalability. We have to make this feel more like people expect, or else you're never going to get the ability of developers replacing the traditional financial system. So we take a different model. And that model is, we call it Radix Engine. I say V2 because we actually have V1 running on the current network. V2 is the upcoming version of it. And that's the version we're going to be talking about today. Radix Engine essentially adds one more feature to the virtual machine. We still have shared computation. You still deploy code there and it still runs on the network. We still have messaging. You can still do that if you want to do to. But we introduce a built-in notion of what we call resources. And resources are what we use to model assets, any type of asset. The reason why that's so powerful is that if you think about DeFi as it today, and again, think of the full scope of DeFi, everything from trading to gaming to NFTs, you name it, every aspect of that is about ownership. It's all about assets. It's all about the fact that I want to write some logic around, I want some logic to say like, oh, I've got a game where this NFT, I can breed these two NFTs together, it produces another animal. Or I want to build something where I can do some exchange or lending or whatever it is. All of this is about manipulating assets. Well, if the reason that we're using a public network is for dealing with assets, why aren't assets a feature of the platform? Why are we forcing people to re-implement the idea of an asset from scratch? Why is it that every single token and every single NFT on the network is a separate individual smart contract where you're just, even if you're copying someone else's code, you still have all this redundant code that's sort of defining, yeah, this is asset-like behavior. And also, any other application can never rely on that asset behavior because it's implemented by someone else that you can't verify. So what we started with is the assumption that we need to have assets available as a fundamental notion of the platform. The platform understands what assets are and how assets should behave. The idea that an asset in the physical world is very intuitive. It's something that I can hold in my hand, I can give it to someone, and there are rules associated with that. It says that, if I've got just a pile of rocks, well, okay, anybody can pick up a rock from the pile and give it to you. However, if I have, for example, a piece of art, it might be that I'm legally not allowed to transfer that piece of art unless it goes through a clearinghouse, something like that. There are all these examples of different types of asset classes in the world. What we do is we teach the Radix platform to understand that set of intuitive physical behaviors so that the developer doesn't have to implement these things from scratch. And it's a really powerful model, and everything else we do wraps around this idea of built-in resource-based assets. And the way we implement this is it's not as if we're building it's not as if we're building a token smart contract into the platform. It's not like we're sort of just running an ERC20 behind the scenes. The way we implement this is with a finite state machine. And I've got a slide that'll actually show you what the finite state machine looks like. But basically, that type of logic, for those of you not familiar with it, it's basically saying it's not arbitrary code. What we say is we define the particular states that something can be in, and you define the rules by which it can transition between those states. The reason that's so powerful is it means that any states that you haven't specifically enumerated are impossible. It means, for example, at the simplest level, it means that the idea of double accounting for a token, or the idea of like a reentrancy problem where it's like, well, I accounted for this token here, but then someone re-entered the call and I double accounted for that token, isn't possible because if you gave that token to another method call, it's now gone. It behaves like a physical thing. It's transition state. So you'll get a more tangible idea of what I mean with this when we start getting into some other stuff. But it's a really, really important notion, and it's the root of why we've taken a very different approach and why we can't use EVM, because it just doesn't have this feature. So let's talk about resources. So resources, again, this is the programming notion of resources. You're going to be issuing resources and interacting with them, and we can use those to model tokens, NFTs, anything you can imagine. So we've got some, this is starting to get into like the things you'll experience in Scripto. You've got some elements that you're going to be working with when you're talking about resources. The first element is the resource manager. So the resource manager is something that it contains an address, it has some flags, it has some metadata that are associated with a given resource. So what I mean by that is, let's say that I want to make Matt's token, and Matt token ultimately is going to have a name, it's going to have a supply, it's going to have some metadata and other things associated with it. I can go to the resource manager for Matt token, and I can get that information. You can kind of think of it as a control panel. The tokens aren't built into it. It's just sort of a control panel that'll tell you where they are, what the description of that token class is. And it also has the functions that you need when you need to deal with it globally. So for example, if I created a Matt token that I want to be mintable, then I would need to go to the resource manager and say, hey, I need 5 more Matt tokens, and you pull the lever and they come out, and now you can do whatever you want with them. Specifically, it does not contain a list of balances or owner addresses. It doesn't operate like an ERC20 contract. It's not as if you're calling this contract and you're doing your transfers through this. When you do a transfer of Matt tokens, you're telling the platform, you're saying, I have 5 Matt tokens and I wish to transfer them to Alice. And the resource manager doesn't come into play. This is purely sort of a convenience control panel that you can use to do global things. The second element is the resource itself. So these have an independent existence on our network. The virtual machine itself understands those resources and manages them, make sure that they're handled correctly. So tokens, NFTs, and other types of assets. We have 2 fundamental types of resources. We have fungible assets and non-fungible assets. The reason those need to be 2 types is that they have pretty specific rules. Fungible assets have divisibility. They all are identical. They don't have individual metadata. They are all interchangeable, as the definition of fungible is. Non-fungibles means that each one of the tokens in that supply has its own identity. It can have its own metadata, and it's basically 0 divisibility. There's one of this non-fungible token, and it is unlike the others, but it's still associated with a certain type. And all those things have this physical behavior customized by resource manager flags, which I'll talk about in a moment. We also have a notion of vaults. This is really important. And again, this is not something that's present on any other platform that I'm aware of. Again, it's a platform native primitive that is a persistent container of a single resource address or a single resource type. So the protocol itself understands the idea that if I have 5 Matt tokens, those Matt tokens need to go into a vault that is able to hold Matt tokens. And each type of token needs to have its own vault. So you don't mix them all in one vault. You have individual vaults for each type. And you'll see, well, I mentioned on here, so vaults are always held within components. I put an asterisk on that because I haven't explained it yet. Components you can kind of think as our form of smart contract. They're a little different, so we give them a different name. But in our case, a smart contract actually holds vaults at a platform level. It understands that idea of ownership. And so when you're putting tokens into a vault, it's always held by some sort of associated component. And the last primitive is we have buckets. So buckets are kind of like vaults, except buckets are transient. So they're a transient container of a single resource address. The reason why we need that is that we need to be able to do transactions with these things. At the end of any transaction, any resources involved need to be in a vault somewhere, because that's the only persistent container. If you ever tried to do something halfway, if you ever took a token out of a vault and then forgot to put it someplace by the end of the transaction's invalid. The platform's going to reject it. The buckets will just give you a way of manipulating them. So we actually, and you'll see this in the language, again, this is something that's quite unique. If you're sending a token, you literally are telling in Scripto code, you would say, I wish to take tokens out of a vault, put them in a bucket, and then I can pass that bucket to a method call. You're not passing a piece of data to the method call that says, hey, please pretend this is 5 tokens. It's just sort of a specification of what I want. You literally are passing a bucket of tokens that the platform understands to the method call, and they operate physically. They behave physically. So I'll go through an example of the life cycle. I'll create Mycoin as a resource. If I wanted to create a coin, a fairly simple coin called Mycoin, it would look something like this. What I would do is in my Scripto code, I would send a call to the platform saying, I wish to create the Mycoin resource manager. And I specify some things at that point. I say, I want the type of this to be fungible. I want the name of this token to be my very own first token. I want the symbol of that to be Mycoin. And I specify that I want it to have a fixed supply of 1 million Mycoins. There's actually quite a bit more complexity in the rules, and I'll get into the rule set, but this is an example of a very simple sort of pile of rocks token that I might want to create. And the result of that call is that the resource manager will be created by the platform. It'll have its own address that can then be used, so it's registered as part of ledger state. And it hands back a bucket of 1 million Mycoin. It said, well, you want a fixed supply of 1 million Mycoin? Cool, here's a bucket of it. You do with it whatever you want to do. And at that point, by the end of that transaction, or by the end of that operation in the component, you need to put it in a vault in some component. You have to deal with where do you want these tokens to end up. You might be handing them off to somebody's user account. You might be keeping track of it in a pool that's inside a piece of smart contract function that you have. It's got to go somewhere because there must be 1 million tokens that exist. So this is basically this is what creation of the token looks like. And it's quite a bit different. Like creation of a token on Ethereum means deploying a smart contract, defining which address has that initial supply, and then thereafter people are interacting with that thing and changing balances. In this case, it's actually instantiating this physical resource that's maintained by the platform itself. So then we can talk about the rules. So resource rules are really, really powerful, and this is an important concept. There's been a lot of talk in our developer forums recently about how powerful this is. In fact, we just posted a blog about, if you've heard of soulbound tokens, Vitalik of Ethereum created a really nice blog about soulbound tokens. And people were asking us like, hey, can you create a soulbound token in this asset-oriented model? And we were like, yeah, it's one line. It's already done. And the reason that's so easy is because of this customizing behavior. This is basically the finite state machine for resources. It's very, very simple. It's the idea that each one of those icons is one of the states that you can be in. So basically, you start in kind of a non-existent state. There is no token. And you mint it. So the first thing you do is, like on the previous slide, you create a resource manager and it spits out some tokens. Those immediately go into a bucket. And then those then can go into a vault. Then maybe you're in a later transaction. You pull those tokens out of the vault into a bucket. And then maybe it goes into a different vault. Or maybe it gets passed from this bucket to another bucket, and then another bucket, and then it goes into a vault. But you kind of ping back and forth between buckets and vaults over the life cycle of that token. And then in the end, for a token where it's allowed, it might also be burned at some point. And then that token ceases to exist. Now the platform says, sorry, you can no longer transact it because it's gone. Each one of those arrows in that diagram, for people that are familiar with state machine logic, that is a state transition. So the idea here is for each resource on the network, and again, I don't mean the resource manager, I mean for each token of Mycoin. If I have 5 Mycoins in my vault, and I want to transact that, what that means is it's saying, right now it's in my vault, and I need to follow the state transition to put it into a bucket, and then put it into a different vault. That's what a transfer looks like for us. And the nice thing about this is this describes the intuitive asset behavior that we expect. Every resource that you can imagine in the world follows this life cycle. It doesn't matter if you're talking about a security or a derivative or an NFT or anything else follows the same basic pattern. And the way we can customize the behavior is by applying rules to those arrows, basically. And so we have a set of things that you can already work with today in Scripto, and we're going to see some of these in action, is that we have these resource rules, we call them access rules, for things like mintable, burnable, restrict withdraw, restrict deposit, updatable metadata, recallable. And we're going to add some additional ones in the future. Basically, each one of these allows you to apply a rule to one of those state transitions. So for example, restrict withdraw means there's a special rule for any time this token wants to leave a vault and go into a bucket, you got to make sure this rule is fulfilled. And the way those rules get fulfilled is by specifying these things called badges, which I'll get into. But basically, badges are it's sort of a usage pattern for a resource. It's another resource type. You can kind of think of it like an NFT, but it's like the badge you use to get into the conference floor. You need to show it to somebody, say, yep, I own this thing, therefore I'm allowed to do this. We actually build that notion into our platform where if I say I want to apply a restrict withdraw, I can say, you can only pull out of the vault if someone flashes the badge that you've said is required to make that happen. This is really cool because now you get to choose who that badge belongs to. It might be an individual or it might be a different smart contract. And now you can start building really complex application logic around that very simple pattern. You can say, okay, this is a soulbound token that by default, you can't pull out of your account because there's some issuing authority that says, I am issuing this to you and you only. You're not allowed to transfer it to anyone else. But if I approve of it, okay, you can move it. So what this means is you need to build a transaction that says, you need to prove to me who you are. And if you've done that, I say, great, I'm going to allow you to transfer it this one time, and I can, in my Scripto code, present the badge to the transaction, and then that fulfills this rule, and you can do that state transition. So the cool thing about this is we describe things in these sort of these physical metaphors to the real world, like how we would build, if you imagine how you would build the system in the real world, you can model that pretty directly in Scripto, and it's very easy to reason about. It's not like you're having to do additional checks of, well, I said I wanted to transfer this, but did it actually get there, and is this, can I rely on this? You're guaranteed that the platform is going to respect these rules. Very, very powerful. Okay, with that in mind, let's go on to components and blueprints. So components and blueprints together are the Radix form of smart contracts. So the reason we don't call them smart contracts is that we sort of split it up into two different parts. Also, I think smart contract is a terrible name because they're neither smart nor contracts, but that's a separate topic. But components and blueprints are a little bit different. We basically split the notion that you're familiar with into these two parts. And the way it works is like this. A component is kind of like the thing you're familiar with. It's like it's something that lives on this in the shared computing environment, and transactions and other components can interact with it. So it has some methods, method 1 and method 2, and you can call those things for it to do different things. There's a little bit of difference in that components can hold vaults. So again, we've got this new notion of vaults. So inside the state of that component is actually a set of vaults. So this component has a vault of Mycoin, and it currently holds 25 of those resources. And it can also have some associated data. This is very common what you see, that like you can have some normal data state that's associated with that component. But what you don't see on that, in that little diagram, is where's the logic? Like where to actually define what method 1 and method 2 do. That isn't actually in the component. Where it is you can see that the name of it is component A, but next to that I'm showing blueprint A, because component A was instantiated from a blueprint. And the idea is that blueprints are these templates for functionality. All of the logic that you write in Scripto is loaded into a blueprint only. When you want to actually make something active on the ledger for people to interact with it in transactions and from other components, is you have to instantiate, you have to instantiate the blueprint into a component. So you have to basically print something from the original template. This is why I call it a blueprint. So, if you imagine, the blueprint is basically all the drawings that tell you how to build a truck. The component is a truck. And you could have different trucks that come from the same basic set of blueprints. This truck is blue, this truck is red, this one has the big engine, this one has the small engine. And the creator of the blueprint can make it parameterized such that when you instantiate, you can tell it what kind of thing do you want. If I built we'll go into some examples, but if I built a basic piece of blueprint functionality, you could have 1,000 different variations on that based on the parameters that the creator specified for this. This is kind of like the factory pattern that you see on Ethereum, but it's actually respected at the ledger level. Every time you're deploying Scripto code to the Radix network, it's deployed as a blueprint first, and then it's instantiated into a component. So one of the cool things about this is it kind of, the blueprint, you have essentially this blueprint catalog that lives on the network, which is kind of like a decentralized GitHub. It's kind of cool. Like you can actually see functionality that is reusable by other developers, and I could go on about that for an hour. So instantiation components is also, this is another, just a variation on this that's important to understand, is that it doesn't have to be one-to-one. So it's very possible for you to build a single blueprint, but that blueprint can instantiate multiple things. So the cool thing about this is if you're building a Dapp, you can imagine building quite complex functionality. Maybe the Dapp that I want to build actually involves 3 different components. Maybe 2 of them come from logic that I wrote, but actually I want to instantiate this other guy that wrote a cool thing, and I want 4 different tokens that come out of this, and all these things work together to create my Dapp in the end. You can build one blueprint that describes all of that, that says when you call the instantiation function on that, so there's typically like a new function that you offer, and that new function can then contain the rules that says, okay, I want to instantiate my component A, my Oracle component, and these 2 different tokens, and then you get buckets of resources that come out, and you can choose where those go. So it's important to understand that it doesn't have to be one-to-one. Like you can build a blueprint that can kind of instantiate this whole system for you. Okay, let's talk about accounts and transactions, because this also changes quite a bit. You can kind of imagine, like in this pattern, it's like, well, where does the account actually come into this? Like on Ethereum, you might be used to the idea of like, well, my account is basically a key pair, and I can go to a smart contract and say, well, I can prove that I own this address, therefore I can change the balance of my token. Well, if we're changing that pattern, then what is an account on our network? And the answer is accounts for us are quite different. As I was saying, on Ethereum, an account looks like this. And again, for people that aren't familiar with Solidity, this might be a little bit surprising. We have another article that we wrote about where are your tokens. Like if you're looking in your crypto wallet today, and this applies to basically every crypto network that exists right now, your wallet is basically just a holder for the key that's associated with this address. And your wallet is going out and interrogating these multiple smart contracts and saying, what's my balance here? What's my balance here? What's my balance here? And then it presents this in this collected view of like, you own these tokens. You don't actually hold tokens in your wallet, which is kind of a surprising notion for some people when they hear it for the first time. Like this is literally how it works on the platforms today. The Radix approach is actually more like what you would expect it the way it to work. Your account is a component. Your account is this thing that lives on Ledger that works, that has certain functions associated with it. So it actually holds vaults, and those vaults actually hold resources, and those resources those are your holdings. So your wallet software on your phone or your laptop is going to be going to your account and saying, hey, what's in my vaults right now? Here you go. Those are your holdings. Very, very direct. And if you want to manipulate this, it operates a lot more like an actual wallet. Like if I want to pay someone my wallet, I take my wallet, I open it up, I pull something out of that, and then I hand it to somebody else. Same thing for us, and you'll see this in a minute. We have a withdraw function that says I want to pull some tokens out of my account, and then I can choose where I deposit those into someone else's account. It's very, very direct. And, some people look at this and go, yeah, I just kind of assumed how it works already, but Radix, from what I can tell, is the only person or the only network approaching it from this point of view, which is kind of weird. So transactions are also then different. I don't show the Ethereum one here, but if you're familiar with Ethereum, essentially a transaction on Ethereum is sending a message, because that's the fundamental functionality it has. You send a message to a smart contract that says, this is what I wish to happen, and then it goes off and runs a bunch of logic, and then you see what the result of that is. Every transaction on Ethereum works that way. Even if you're doing like a composed smart contract call with multiple contracts, you're usually talking to a kind of a lead contract. You're saying, I want to do this composed transaction, and then behind the scenes it's going out and talking to four other smart contracts, and you get an overall result. In our case, it's very, very different. Our transactions actually speak in terms of resources, because everything's about resources for us. In our case, the transaction would look something like this. It's a little bit graphical, but you'll see the real thing in shortly here. The transaction describes asset flows. So if I want to do a send from Alice's account to Bob's account, that transaction says, I'm calling Alice's account withdraw method, and I'm saying, hey, I want 5 SERB tokens. Alice's account checks the fact that, make sure that Alice is who she says she is, so it verifies the signatures. Assuming that she has the right signatures to control that account, those 5 SERB tokens get passed back in a bucket. So you now have a bucket of 5 tokens that's in the transaction context. And the second line of the transaction says, cool, I want to take that bucket and pass it into the deposit method on Bob's account. So again, this works just like how pulling your wallet out of your pocket actually works. I withdraw from my wallet, and Bob basically opens his wallet and says, yep, you can put it in there, that's fine, cool, there's your $5. So very intuitive. And this transaction, we call it the transaction manifest, you'll get into this, is very, very powerful, because it means you can do composed transactions across many components in the transaction. You don't have to deploy a separate smart contract to do that. You can describe asset flows. You can have a transaction that might say, first of all, I want to get a badge that allows me to use a flash loan, and that flash loan gives me these tokens, and I'm going to use those to take advantage of an arbitrage opportunity. Then I take those things, I stake it someplace else, and then I get something else to pay my loan back. You can just describe that line by line in the transaction manifest of where you want those buckets to go. And as long as everything is valid, the transaction goes through, and it all happens at once. It's called atomic composability. The entire thing happens at once, or if any step of that was invalid, like, for example, if you didn't pay the flash loan back by the end of the transaction, then the whole thing fails, because you tried to do something that was invalid. Very, very powerful notion. Okay, last thing before we start getting into real code is talking about the Toolchain Roadmap, so a little bit of context. So, again, this is fairly similar to Ethereum, but I want to describe what the Dapps stack looks like. When you talk about a Dapp, what do I actually mean? It's not just the smart contract. It's not just the components on the ledger. There's kind of an ecosystem, and I want to present, like, if you're thinking about, if I'm trying to convince you guys to be Dapp developers, what am I expecting you to build? It's this. So a Dapp looks something like this, and this is basically the Web3 pattern, is that you have the main parts of your application are, there's a part that runs on the network, and that's the component. That's the smart contract part of it. You can kind of think it, in the traditional Web 2 model, you can kind of think of it as the back end. So typically for a normal application, you've got some backend that's running on a server, and then you've got your front end. The front end is a mobile app, or it's a web page, or something like that. This kind of a similar pattern here, but rather than having a centralized server backend, you're using the network itself. So you deploy your backend logic, your smart contracts to that network, and then you have a front end to that. And the front end takes two parts. There's your own UI, and typically this is going to be a web application. This is the new pattern. And then that web application it understands what it means to interact with your backend. It understands, I have deployed a component that knows how to do swaps between two different tokens, or knows how to conduct the game rules of an NFT system. And the front end basically knows how to compose transactions, write up transaction manifests, like I said, that can interact with those things. And it presents a user interface to the individual. So if you imagine an exchange, you've got a web interface that says, okay, I'm going to swap between token A, token B, that sounds good, click send. And when it clicks send, it creates a transaction manifest that's passed to that user's wallet. The wallet allows the user to sign that transaction to say, yes, this is indeed the thing that I want to do. Because remember, we've got an open network where everyone controls their own assets. I don't store my money with the application. I'm holding it in my own wallet. So if the application says, it's saying, I can do a trade for you out of your wallet, it has to tell the wallet, say, here's what I think you've requested that I do. Make sure you're okay with this, and then you get to submit to the network. You're in control. Let me get to that. So this is what the overall stack looks like in the end, is basically, and we've got a number of people in our community. Some people specialize in the back-end part and the component part. Some people specialize in just building really cool front ends that they can interact with these things. So there's room for both types of developer in here. Today, as a Scripto V0.4, and I'll get to this in the roadmap, so we're kind of in the pre-release version of Scripto right now. Right now, what we can offer is the network. We have a simulator environment, and we also have something we're calling the public test environment. So it kind of acts like a network and allows you to start getting through deployment testing. We don't actually have a consensus network behind it because that's going to merge in the next point in our roadmap. I'll talk about that. And then the wallet right now is something that we're currently in build on. I would love to talk about the wallet because there's some really cool stuff that we're doing there, but we're trying to kind of keep it stealth mode right now. But basically, there will be a wallet on the network that will allow you to will give the user this really nice sense of control of their assets. Right now, what we basically have is a developer tool. It's a browser extension that operates kind of like MetaMask that allows you to interact with a web application, receive transactions, sign them, and submit them to the PT environment. So this basically what we do is we have a prototype version of this Dapps stack, so you can start working on that today. You can start building applications, both parts of the application, experiencing what Scripto is like, starting to plan for what you want to deploy to the network. A little bit more technical detail. So this is a little bit deep, but for people who want to understand a little bit more about what we mean by Scripto. So Scripto is essentially a set of extensions for Rust. If you're familiar with Rust, good deal. You've got a little bit of a head start on some stuff. But basically, we have, as you can imagine, I wanted to go through this other stuff first so you understand the context. We've added quite a lot of syntax and functionality to Rust. So you still have available to all the normal Rust syntax, and Rust is a fantastic language, and we're a huge fan of it. But then we've added all this asset-oriented language to it. We've added functions that allow you to take assets and put assets and create resource managers and use vaults and all those sorts of things. Rust doesn't know about those things, so we've introduced language primitives and some data structures that allow you to do those sorts of things specifically for Radix. And that set of extensions is basically what we call Scripto. So if you want to call it Scripto, it's kind of a domain-specific language in a way because it's sort of based on Rust, but we call it a language basically because we find that most people are spending most of their time interacting with the particular asset syntax rather than core Rust, but it's all available to you. So the idea here is when you're writing a piece of Scripto code, you're combining that code with a standard library that we provide. This runs through the standard Rust compiler with the Scripto extension applied to it, and this ultimately becomes a piece of compiled WASM. That WASM is then deployed to, it will be the network. Right now it's to the simulator or the PTE environment, and that then can be run by the Radix Engine, and the state of those things is recorded to the ledger. So for right now, it's a file system-based ledger. Ultimately, it's going to be the public network where it's shared and open. Okay, last bit before we get into code. I want to talk about roadmap, because it's really important to understand where we are in this journey. The network that we have right now is what we call the Olympia version of the network. We launched this last June. It's currently operating. It's a fully decentralized network. The Radix token is there. There's a bunch of people that have been creating third-party tokens on that network, and it's been ticking along reliably since then. It's very simple, though. The current network, does not have Scripto currently. It has no smart contract functionality. It actually is using the resource model that I talked about. Like tokens on the current network are actually platform native. It's just that you can't write any extra logic around it. You can just sort of go to the platform and say, hey, I want a token. And it goes, cool, here you go, and you can transact it around. It's very simple. But basically, the purpose is that we wanted to get a decentralized network out. We wanted to build a relationship with node runners that were going to be operating that network. We wanted to prove a basic form of our consensus mechanism. And we want this to be the foundation for further development. So that's currently running. You can currently interact with it. The next step on the roadmap is Alexandria. This was released in Q4 of last year, in December. And the focus of the release was enabling Scripto developer pioneers. This is where we are right now, and that's who you are, Scripto developer pioneers. So the first version release was V0.1. Right now we're on V0.4. 0.5 is coming very shortly, probably in a few weeks. And basically, this is now an off-ledger system that we've added, so it's kind of a parallel system. We have the Olympia network that's currently running, and currently we have the Radix Engine V2 simulators, we've got some CLI tools, and in the back half of this year, we're going to start having test networks that allow you to start deploying applications as you would to the real network. The next milestone after that is Babylon. This is where these two tracks come together. So Babylon will be in Q1 of next year, and this is where Scripto functionality, Radix Engine are going to migrate to the public network. This will then be where you can actually deploy your first smart contracts to the network, and you can start doing business as usual, and you can start building DeFi on the network. So our goal here is to enable people in Alexandria to start building, to start exploring concepts, to start connecting with each other in community, to start basically proving to the world that you can build these amazing DeFi things in a much more easy way, much more safe way on Radix, and have everyone be ready so that on day one of Babylon, everyone's going, great, I know exactly what I'm going to deploy, I can deploy to the network, and I'm going to be one of the very first people on the Radix network that's building a better kind of DeFi. So this is what we're trying to get in everyone's mind is be planning for Babylon. Babylon is where things are going to get really exciting. And by the way, this is also where we're going to have the brand new wallet that's built for DeFi and Web3 that we're working on. So basically at the end of this year, we're going to be launching that wallet concept, and we'll be able to show you a lot more. And then we've got one more planned roadmap after that. Obviously, it'll continue, but one more milestone that I want to talk about is what we call Xi'an. This is right now estimated to be 2024, but the idea here is this is where we get to our fully sharded Cerberus consensus model. This is where we get to the scalability aspect of it. In our opinion, is the first problem we needed to solve was the buildability problem, because this is really what's holding people back, is the fact that it is awful to build reliable smart contracts today. So the plan here is that you start building now, you start deploying on Babylon, we start building momentum, and then we follow that with the Xi'an, where we migrate to the network to now we're not going to stand in the way of anyone's success. We're going to scale to the point where now we can handle millions of concurrent applications that are running through this network. We don't need that in the beginning because we're not going to have millions of concurrent applications on day one. The Babylon network is going to do, it's still going to have 3 or 4 times the throughput of Ethereum as it is today. We feel like that's pretty good because DeFi is on Ethereum today. Then when we get to Xi'an, this is where we get to unlimited scalability. This is where we get to unlimited parallelization as we'd expect from something running on the internet. Last slide, notable coming updates. So as you're going through here, what we're going to be going through today is Scripto 0.4. So you're aware, we've got some things that are planned that are going to be coming soon. So shortly, we're going to be having some continued refinements to the resource and component authorization model. You're going to get more into that authorization model in Clement's presentations. This is the badge concept that I talk about. We're still refining that. We have a basic format, but it's continuing to improve a little bit. And then coming by Scripto V1.0, which is going to be the Babylon beta net at the end of this year, we're planning on being feature complete for the mainnet launch at that point. Scripto V1.0 fee is where we're going to get transaction fees. Obviously, we need to have that. Currently, we don't have that because there's not much point in transaction fees when you're running on a local network, but that will be coming a little later. We also have a really interesting royalty system that I could spend another hour on, but I won't go into it. But basically, it's the idea that if you're deploying really great blueprints and components to the network, and if people are using those things, you have a way of being able to specify directly a royalty and get paid transaction by transaction for real usage of your stuff, which I think is a pretty powerful concept for building a developer community. Also, real test networks, again, are coming later in the year. Right now, we have the private environment. We've got AlphaNet and BetaNet coming soon. And then also, we have our gateway API. So you can imagine that both the front end and the wallet needs to interact with the network in various ways. The way we do that is what we call through the gateway. The gateway is basically an API that allows you to query ledger state, send transactions to the network. We have a version of the Gateway API that's running on the current Olympia network that's going to be migrating to one that's built for smart contracts for Babylon that will allow you to, for example, query the state of an individual component or get events that result from transactions that get committed, all that sort of thing. So there will be a migration of that as well. And of course, the full DeFi wallet. So that's the introduction to Scripto. Thanks. Where we're going to go after this, yeah, you don't have to clap, it's fine. I wasn't fishing. Coming up next is, and Clement's going to come straight on here and dive into it. So now that you've got the basics of the concepts, we're now going to start writing code. We're going to start very, very simple, and we're going to build up progressively to, by the end of the day, we're actually going to be building a decentralized exchange using Scripto, and you're going to see how easy that is. So with that, I'm going to introduce Clement, who's our developer liaison.
Hi everyone, I hope you have a good day. So my name is Clement. I'm developer community liaison at RDXWorks. What this means is that, in short, I make sure that the developers learning Scripto, they have a good time in our community and they have all the resources they need to get started in that language. So just a question, who has worked with Solidity in the past? Raise your hand. And keep your hand up if you actually like the experience. If you've liked this experience, you're going to really love this, what I'm going to show you. So I asked this question because I really like showing Scripto code to people who've worked with Solidity, because they understand straight away that how a game changer is Scripto is. So this is going to be the agenda for today. We're going to be starting simple with Hello World example, and then a gumball machine where people can send XRD to a component to get back a gumball token. And then we're going to start building more complex stuff related to NFTs, because this is something that people really love and are asking a lot. So the first example with NFT will be just like any other image NFT that you see. It's going to be a board gumball club NFT. And the next one, after that, we are going to be building something more concrete with NFTs. It's going to be an event ticket system, where each ticket to enter the event will be represented as an NFT. And finally, the last part, I'm going to go through the Radix Swap, which is just like Uni Swap, but on Radix with Scripto. So to follow this workshop, you will need a couple of things. First, you need an IDE that supports Rust. We highly recommend VS Code, not Visual Studio. It's different. And you will need to install the Rust Analyzer extension to get the language suggestion and stuff like this. And then you will need to install the Scripto simulator and library. You do this by going to the link on the screen, and you have all the instructions to install it. If you are here, you should have received an email explaining how to set up already, so you should already be ready. And finally, you have to clone the code that we will go through. This is on GitHub, so simply go on the Scripto tutorial repository, clone or download the code, and you will be able to follow along. So the first example we will go through, Hello World. It will teach you the basic structure of a blueprint, how to create a token, and how to use Radix Engine Simulator, Resin, which is the command line tool that comes with when you install the simulator. And this, you will learn how to use this to test your blueprint on your local machine. This is a diagram of how it will look like. So a user will call a free token method to get a hello token. And so let's get into the code. So Just as an introduction to get started, you should go ahead and follow the instructions in the README. It has some explanation about the example that we will go through. And especially if you are on Windows, you have to make sure that you follow the instructions on how to get it working with the PowerShell. Because we are going to be running some scripts, and you need to do something to be able to run them on the PowerShell. And also, we are going to be running some transaction manifest. And if you want to have the colors when reading those files, you should right-click on the RTM color file that comes in the repository and click on Install Extension. So this is an extension that we made to add some syntax highlighting in the transaction manifest. So for the Hello World example, open up the first directory. And all of your blueprint code will be stored inside the lib.rs file, or you can split it in multiple files and import them in this lib.rs file in case you build like a really big blueprint. But right now it's really simple, so all the logic will be in the lib.rs file. So when you open up this file, you will see that how a basic blueprint looks like. So the first line, this is where we import the Scripto library, which gives us access to Scripto types such as buckets, vaults, and also allows you to gives you some methods to create tokens and everything that you will need. And next, we call the blueprint macro. And inside this macro, this is where we actually define the blueprint. The first part, the struct, this is where you define the variable that will be present in each of the components that you will instantiate from this blueprint. In our case, there's only one variable. It's called sample vault, and it's of type vault. So if you remember a vault, this is what is used to store tokens inside your account or any other components. And we will use this vault to store our Hello token that the user will be able to request. The next part of the blueprint is the implementation. This is where you write the functions that people are able to call on your blueprint. And this is also where you define the methods that you call on your components. The methods and functions are, the difference is if you call it on a blueprint or on a component. Because on a component, you will have access to the state, but not on a function. So the first function that we have, it's instantiate hello. So like Matt was saying, so when you have a blueprint that actually have the code, you cannot use it right away. You have to instantiate a component from it. And this is the goal of this function. So when someone calls the instantiate hello function, you can see that it returns a component address. So this is Rust syntax for returning things from function calls. And so the goal of this, inside this function, the first thing we do is we create a new resource. And look at how simple it is. You don't have to create an external smart contract just to get this working. You call the resource builder, and you specify if you want to create a fungible or non-fungible resource. And then you can put some metadata. In our case, we put a name and a symbol. You can put anything you want. And then finally, we initialize this resource with an initial supply of 1,000. You could decide to create a resource with no initial supply, but that is mintable or burnable, like the flags that Matt went through earlier. And after calling this method, it actually returns those 1,000 resources inside a bucket. So we are storing it inside the myBucket variable. And then we are initializing the component and our state. So we initialize the state by writing self, like this. And then we have to assign a value for each of the variable that we specified in the struct earlier. So we specify a value for sample vault. And we can initialize a vault with a bucket by calling vault with bucket function. And then you provide the bucket that we just got from the resource builder. So this will essentially store the 1,000 resources stored on the bucket inside the vault. And then from this state, when we set up the state, we have to instantiate a component from it. So we call the instantiate method on this state. But this gives us only a local component that you can use inside this function, or and add some authentication that we will see later. But in our case, to keep it simple, we won't do this. So we have to call the globalize method right away, and this assigns an address to this component, and thus allows people to be able to call methods on it. And the globalized method actually returns a component address, which is what we have to return from this function, from what I explained earlier. And to return stuff from a function, you don't have to write a return statement with Rust. You simply have to write the function call that you want the thing that you want to return, and remove the semicolon at the end. This will automatically return the result. So this is it for this instantiate hello function. And now for the free token method. This is a method that people will call to request a hello token from this component. So notice that in the parameters we have a reference to self, a mutable reference to self actually. And we need this because we will call this on a component, and we want to have access to the variables that we configure. So to be able to take a token from the sample vault that we initialized. And it has to be mutable because we are actually going to be updating the state of the component on which you are calling this method. And finally, this method actually returns a bucket back to the user, and it will contain the token the user is requesting. The first step inside this method, we are actually just outputting some information in the console and in the log results just to show what's the balance of this component. And we can get the amount of tokens stored inside the sample vault by simply calling the amount method on the vault itself. And then we want to take a single token from this same vault and return it back to the user. And remember, we don't have to write this return statement. This is the same as writing this, but it's simpler. So the result of the take method will automatically be returned back to the user. So now that we went through this example, we are actually going to try it on our local simulator. So open up a terminal by going to the top and clicking on New Terminal. And if you want to do this on your own, you have all the instruction inside the README in the first directory. So the first step is to actually reset the simulator, just in case you've played around with Scripto before and you already have some components, some blueprints on your local simulator. So do resin reset. And then we are going to be creating an account. This is the account from which we are going to call the components and on which we are going to store the hello token inside. So we can create a new account in the simulator with resin new account. And when this is done, this gives us back the address of the account component, its public key and private key. We are going to be actually using the account address. And to refer to it more easily, I'm going to save it in a shell variable, like this. This is the syntax for Mac and Linux. If you are on Windows using the PowerShell, you should do $account equal quotes, and then you put the address like this. And remember, you have to use the PowerShell. If you use the command prompt, is going to be a different syntax. Okay, so now that we have our account, we can now publish the code that I just showed you by doing resin publish. And we have to write the directory containing our package. So this is this is inside the first directory, so I'll write this. So resin publish and then the directory. So now it is building the code, and once it's built, it's going to deploy it on the simulator. And once it's deployed, we now have an address that we can refer to call functions on this blueprint. So this is the package address that we need. And now we want to call the instantiate hello function on this blueprint. We do this by doing resin call function. And then we need to provide the address of the package that we just published. So just copy and paste the address that you just got from the resin publish command. And then we have to provide the name of the blueprint, because a package can actually contain multiple blueprints if you are doing more complex stuff. In our case, it's named hello. This is the name so that you can create different components with different parameters from the blueprint. And you will also learn how to accept a payment from the user to get the token. So it's going to be a little bit similar to the last example, but with more functionality. So open up the second directory and go inside the lib.rs file again. And you can already see that it gets a little bit more complex because the variables in the states inside this struct section, we are now having more of them. We first have a vault to store the gumballs, just like we did in our last example to store the yellow token. But we also need a vault to store the collected XRD that the user is sending us. And then we need a variable to hold the price because we want the components instantiator to be able to provide a price. So that's what we are doing inside this function, this instantiator function. We added a parameter called price of type decimal, and this will allow the instantiator to specify a price when instantiating the component, so that people can create multiple components from this blueprint, but with different price. Again, inside this function, we are creating a token. Now we name it gumball, and notice that there's a new line, the divisibility of the token. So Scripto allows you to specify the divisibility of your tokens. In our case, we specify a divisibility of none, meaning that the gumballs that you receive, you won't be able to split them. So you won't be able to send 0.5 gum token to someone. You have to send them by one. And then this is we are actually storing this inside a bucket again. And just like in the previous example, we are instantiating all the variables of the state. So the gumballs, again, is going to be a new vault with a bucket. But the collected XRD is going to be a vault that stores the Radix token. So we don't already have a bucket of it. So to create this vault, we can call the vault new function. And then we have to provide the resource address that this vault will contain. In our case, it's Radix tokens. And then we specify the price, which is equal to the price that was provided from the parameters. And again, we instantiate and globalize it to get back a component address and return it. Now for the buy gumball method, again, we have the self, a reference to self to have access to our state variables, but we now also have a payment variable, a payment parameter, I mean. And this is of type bucket, and this will be provided by the user, which will be the payment to get back this gumball. And notice how we return 2 buckets now instead of 1. We could do it by only returning 1, containing the gumballs, but let's say the user sent more than the required amount. We could actually just, if the price is 15 XRD, we could ask the user to send exactly 15 XRD to this method. But if we want the user to be able to send how many they want, so we add another bucket to the return statement, and this will be the change that we give back to the user. So again, we are outputting some information. We are saying that we are buying a gumball. This will be useful for later when we do composability. And then we are taking from the payment bucket a number of XRD depending on the price that is stored inside this component. And we will store it inside the hour share variable. And we will put this hour share bucket inside the collected XRD vault that we defined earlier. And then we take 1 gumball from the gumball's vault, just like we did in the previous example. And we are returning the gumball along with the payment bucket. So let's say the price was 15 XRD. At the line 36, we take 15 XRD from it. So there's 5 XRDs left inside this bucket. And if there's 5 XRD left, we are going to return it back to the user. If we actually forget to return this change to the user, actually the Radix Engine will protect the user and will make the transaction fail, because where would the 5 XRD be stored otherwise? It would be lost inside this method. So actually, you cannot have you cannot have buckets containing any resources by the end of a transaction. They have to be stored inside a vault, and this is really important. Either inside a component, the component vault, or in a vault inside the account that called this method, like we are doing now. So now that I'm done explaining this, we are going to run it. So open up the terminal again. And you have all the instruction inside the README in the second directory. So the first step, we are going to be storing the XRD address inside a variable to be able to reference it more easily. So if you're on Linux or Mac, you can do the export command. If you're on Windows using the PowerShell, just like I showed you earlier, you can do the same thing, but with a different syntax. So I'm going to do the first one. And then again, we want to reset the environment, because to remove the blueprint that we published earlier. And we are going to be creating a new account. And again, I'm going to store this inside the account variable with the export command. And then I'm going to publish this package to the local simulator with the resin publish command, which requires us to give it the directory containing the package. So in our case, this is the second directory. So now that we have the package, we want to instantiate a component from this blueprint. Again, we do this with resin call function. We put the address that we just received from the resin publish command. Next, we put the name of the blueprint. In our case, this is gumball machine. And then the name of the method, so instantiate machine. And next is the parameters that this function requires us to provide, so the price. Let's try to put 25. This means that the user, to be able to call this by gumball method and receive 1 gumball, they will have to provide us with at least 25 XRD. Again, this is giving us a component address and the resource address that represents the gumball that we instantiated, that we created inside this function. So I'll save this component inside the component variable. And now I'm going to be calling the by gumball method on this component with resin call method, the address of the component that I stored inside the component variable, and then the name of the method that we want to call, so by gumball. And now we need to provide a bucket to this method. How do we do this? Resin allows you to do a simple syntax to represent buckets. So you write the amount that you want to send. In our case, it's 25. And you provide you put a comma, and you provide the address of the resource that you want to send. In our case, it's the XRD address that I stored on the first step inside the README. So when you run this, you should see a success message and the output that we wrote inside this method. So it writes buying a gumball, so it means that everything worked. So let's verify inside our account that we receive this gumball with resim show and then the address of the account. And you can see that we now have 1 gum token. Now let's try to trick the system, and let's try to buy a gumball for 10 XRD to see what it does. Because you should have noticed that we didn't actually put any checks in and the buy gumball method, we didn't put any checks on the payment bucket. Like we didn't specify that the bucket must be at least 25 XRD. We didn't provide that we didn't check that it has to be of type XRD, because the user could send us anything, actually. So let's see what it does. So we send 10 XRD, and there you go. We have an error that says insufficient balance. And this is what's nice about Scripto, is that you don't actually have to do to handle all the edge cases. All of those is handled by the platform. For example, in our case, this is when we are taking the price from the payment bucket. It sees that you didn't send enough to be able to take this price from the bucket, so it fails. And it's the same thing if the user tries to trick the system, and instead of sending XRD, they send another token. This will raise an error when we are trying to store the token inside the collected XRD vault, because we initialize the vault with the XRD address to make sure that only XRD can be stored inside. So this is it for this first introduction. We're going to be having a questions round. And after that, we are going to have a lunch, and we are going to continue again with the NFT section after that. So go on Slido and ask your questions, and I will be answering questions related to Scripto. So someone is asking, why is the Radix engine so important? Can't it be just any engine like the... I get this question a lot. Some people ask, why not use the EVM or something else? Why we have to use the Radix engine is because of the asset-oriented approach that we are going with. So you saw how easy it is to create tokens. This is because the platforms allows it. The Radix engine allows it. So you don't have to create external smart contracts just to create your tokens. So that's why we have the Radix engine. It also ensures the security when you're moving the tokens around. That's why we have to put them inside buckets and send them, change the ownership to the component once we send it to them, once they have it. So someone is asking, is Resim the Radix CLI? Resim is only for testing purposes at the moment. There's no Radix CLI right now. So Resim is only to communicate with the local simulator to test your blueprint and test Scripto in this early stage. And is there only one resource manager per resource type, or can a resource manager have multiple resource type? A resource manager can only have one type, because this is the definition of the resource. It wouldn't make sense to have multiple resource represented by one manager. What is the biggest difference between Scripto and Solidity in terms of UX from a developer perspective? So from a developer perspective, hopefully you saw how more easily it is to move assets around and create tokens, because the developer doesn't have to implement everything from scratch using Scripto. A lot of things is now handled by the platform instead, which makes it more easy for the developer. They can get from an ID to a prototype more quicker and more easily. What would happen if you instantiate a component with a price of 25.5 XRD? Because we accept a decimal parameter, the user can actually provide a price of 25.5 XRD, and it would work. There would be no issues with that. That's because this is the decimal type. Actually, Scripto doesn't support floating numbers, and this is for some reasons. But so that's why we have the decimal type, and it allows you to send some fractions of tokens, as long as the divisibility of the token is not 0. How does gas work on Radix and Scripto? Right now on the simulator, there's no gas implemented, but this is something we want to we will have before the next release in Babylon, so that you are able to test in a real environment with gas and paying for your transaction. So we've got a question. What is the Radix organization hoping to accomplish by the end of this event? So in short, we want you to get a feel of Scripto, just to be able to go on your own and join the community and have an idea about how you can use Scripto to make to try your ideas by yourself. So that's why we are going through different examples from easy to more complicated, so that you can hopefully be able to get the idea that you have in your head inside Scripto. So I guess we will have lunch, and after that we will be doing the NFT part. So see you later. Thank you. Welcome back, everyone. So we are going to be starting the next section now about NFTs. So for the next example we are going to go through, we are going to be building image, artwork NFT, which we will call the Board Gumball Club. And during this example, you will learn how to apply the concepts of badges that Matt talked about. This is, just to remind you, this is how we do authorization and authentication on Scripto using assets. You will also learn how to create non-fungible resources and how to provide some flags and authority on those resources. And finally, how to mint new resource. So you can see the diagram of what we are going to be building. It's going to be the Board Gumball Club blueprint. It will have a instantiate club function to instantiate the component from this blueprint, and it will provide 3 methods. One for the admin that will be able to call it to mint some new NFTs, and then 2 methods to buy the gumball NFTs for the user. One for getting a random one, and another one to select which NFT ID they want to buy. Also, you will learn how to use the transaction manifest. And again, this is to create more complex transactions with multiple steps. We are going to be using it to as the admin when we want to mint the NFTs by calling the mint NFT method, instead of having to call it to create three different calls, 3 different transactions. We are all going to do them in a single one by specifying line by line in the transaction manifest those calls. So open up VS Code again. And go into the third directory, and now you will see that in the source directory we have now 2 files. This is just to show you how you are able to use Rust syntax to work with multiple files to separate your logic in your blueprint once it gets more complicated, like in our case. So, like before, we have our lib.rs file where we define the blueprint logic and the data. But also, if you look into the attributes.rs, this is where we define the different attributes for our NFTs. So each of our NFTs will have a different gumball color. They will each have a different at and different high types. So this is how we define so we define those attributes inside enums, and we are going to be using them inside the lib.rs file. So you can already see a little difference in the lib.rs file. This is because we are now importing this attributes.rs file with those instructions. So we are specifying that we want to use this attributes file and which enums that we want to use from that file. Next, we are going to define the data that each of the NFTs will hold. We do this with a struct. And the struct, we will name it gumball NFT data. And we have to add this line, derive non-fungible data, just to specify in our Scripto code that this will be a structure used for our NFTs. Next, in the blueprint section, you can see the struct is already getting more complicated because we now need to store more information and the component. So we have a gumball NFTs vault, which will hold the NFT that the admin creates. And then we store the resource address of the gumball NFT. And this is to be able to mint more of this resource later. We have a vault for the collected XRE, just like in our two previous examples. And then we have a price for when someone wants to buy a random one, and also a price for when they want to buy a specific one. Those two prices will be specified by the component instantiator through parameters of the instantiator function, just like we saw in the previous example. Next, we are storing the resource address of the admin badge. The admin badge will be used to protect the mint NFT method to make sure that not everybody can call it. You have to prove that you are the admin of this component to be able to do it. Next, we have a vault that we call minting authority. This vault will contain the badge that is allowed to mint the gumball NFTs. So the badges can be stored inside an account, or it can also be stored inside a component. In our case, we want the component to be able to mint the NFTs. So that's why we have to store it inside the components state, instead of like sending it to the admin and having the admin minting it directly. And the final variable that we will keep track of is the number of NFT that we've currently minted. And this will be to set an incrementing number for the ID of each of the NFT that you create. So for the instantiator function that we call instantiate club, you can see that we have two parameters. So the price for random and the price for specific. Again, this will be specified by the caller, the person instantiating the component. The next step is we are creating the admin badge that will represent the admin. So this badge, we will return it back to the user at the end of this function call. So the person calling it will have the admin badge and will be able to prove that they are actually the admin. And then we need to do something similar, but for the minting authority. This will also be the same as an admin badge, but used to show that you are able to mint the NFTs. So again, to create a token, you simply do resource builder, and you can provide some metadata and an initial supply. And in the next step, you can see how to actually create a non-fungible Since the beginning of those workshops, you saw how to create fungible resources, but this is now the first time you see how to create a non-fungible one. And as you can see, it's pretty similar to the other type of tokens. It's still simple. You just have to change this to, you call the new non-fungible function on the resource builder. You also provide some metadata. And now notice that we provide a flag, the flag mintable. And this means that these resources that we are creating will be mintable. And we provide a rule for who is able to mint this resource we are creating. In our case, we are simply requiring the user to prove that they own the minting authority. Well, I say the user, but in our case, it will be the component that holds this minting authority. So, and you can also see that we've locked this flag because we don't need to change it later on. If you wanted to, you could be able to provide like. You can change this parameter to say that you can actually change who is able to mint it, or just remove this rule to make it non-mintable in the future. But in our case, we will keep it simple and keep it like this. And notice that we don't create an initial supply right now, because we will be creating the supply when the admin will call the method on the component. And again, we now have to set up the state of the component we want to instantiate. So we have to set a value for each of the variables. So we have some volts, we have the price that is provided from the parameters, and we initialize the number of NFT minted to 0. So now that the state is set up, we call the instantiate method on it to get a local component. And notice that I don't globalize it right away. That's because before globalizing it, I want to add some access rules to it, because I want to protect this mint NFT method that we can see just under the function. Because I want this method to only be callable by the person owning the admin badge. So I do this by creating a new access rules with access rules new. And then I provide the rules for the mint NFT method, which is we are requiring the person to prove that they own the admin badge. And then we put the default for each of the other methods to be callable by everyone. Then, before globalizing the component, we have to add those access rules to it. So that's what we do with the component.addAccessCheck, and we provide the access rule that we just created. And then we globalize it. Again, when we globalize the local component, it associates an address to it so that people are able to call methods. We are also returning the admin badge back to the user. Again, this is to make sure that the person instantiating the component, they have a proof, they have the badge to show that they are the admin, to call the protected method. For the next method, so mint NFT. So it has a reference to self, because it's a method that we call on component. And again, this gives us access to the state of the component. And then the admin that is calling this method, they have to provide a color, a hat, and the height type for the NFT they want to create. The first step we do inside this method is to get the ID of the NFT that we will create. In our case, like I said, we want it to be an incrementing number. So it will just be a non-fungible ID from a unsigned integer, which is the number of NFT that we minted plus 1. The next step is to actually define the data that this NFT will hold. So we create an NFT data variable, and its value is an instantiation of the Gumball NFT data structure that we defined earlier at the top of the file, here. So now that we have those information, we are able to mint the NFT that we want. To mint an NFT, the component have to prove that they own the minting authority that we assigned earlier on the NFT resource. So we can do this by calling the vault that holds this badge, so self.minting authority, and then we call authorize method on it. And the authorize method accepts a function, and within this function, so this block here, the badge will be put on something that we call the authorization zone. So whatever you do within this function, it will have a proof that the admin badge was shown. So that's why we do inside we can do mint non-fungible. So we first borrow the resource manager of the Gumball NFT, and that's why we saved the address of the NFT resource earlier. So we need to get the resource manager to be able to mint a non-fungible token. So we call mint non-fungible. And this accepts as parameter the non-fungible ID that we created, and also the data. And this returns us a bucket containing this NFT. And we are returning it from this function and storing it inside the new NFT variable. Then we simply have to insert it inside the Gumball NFTs vault from inside the component and increase the number of NFT that we minted. Pretty simple, right? To mint new resources. No need to define the logic yourself for minting and also for burning, but not in our case. So now the two methods to allow the people to buy the NFTs that the admin created. So buy random. It accepts a payment from the user. And just like the previous example with the Gumball machine, we are returning two buckets. The first one will contain the NFT. The other one will contain the change, just in case the user sent more than the required amount. So the first step inside this method is to insert inside the collected XRD vault a portion of the payment bucket depending on the price. To take a portion from the payment bucket, we can simply call the take method with the amount that we want to take, and we put inside the vault by calling the put method on the vault. And then we take an NFT from the Gumball NFTs vault, and we simply specify that we want to take one without specifying which ID that we want to take. And then finally we have to return the NFT along with the change. To buy a specific NFT, it's pretty similar, except that in the parameters, you are actually accepting an ID, which is unsigned 64. So the user will provide the ID of the NFT they want to buy, and the difference resides in this line. Instead of doing take and providing only the amount that we want to take, we provide the ID that we want. So we call instead take non-fungible, and we provide the ID that we want to take. We return it along with the change again. Okay, so now that we are done with this, with the code, we are going to go into the terminal, and we are going to build it and try it on the local simulator. So open up the README file, and you will have all the instructions to test it. So first step is I'm going to save this the XRD resource address inside a variable to refer to it later. Again, if you are on Windows using the PowerShell, the command is a little bit different to save variables. We then need to do resim reset to remove the blueprint and all the things that we deployed in the previous example. And then again, we do resim new account to create the account from which we are going to call the methods. And I'm going to save the address of this account inside the account variable. The next step is to build our code and deploy it. We can do it with resin publish. And this command requires us to provide the directory containing the package. So in our case, it's this third directory. So I'm going to wait a little bit just to make sure everyone gets this published, because some people it was taking more time. So now that we have the package address, we can call the instantiate club function with it. So again, like the previous examples we went through, we do it with a resin call function. We provide the address of the package containing our blueprint. And then we write the name of the blueprint. In our case, it's right here, board gumball club. And then the name of the function, which is instantiate club. And now we have to provide a price for random and a price for specific NFT. The price for random, let's put 15. And the price for specific, let's put it a little bit more, so 30, just because they have the choice on which NFT they get. So after running this command, you should see a success message, along with all the new entities that were created during this function call. So you can see the component address. The first resource is the admin badge that we created. The next one is the minting authority. And the last one is the actual NFT itself, the resource address of the NFT. So we're going to save this this component address inside the component variable, just to refer to it more easily. And then we're going to need also to save the admin badge, which is, remember, this is the first resource address that you see in the new entities log message. So now, like I said earlier, we are going to be minting the NFTs, but we are going to be minting 3 NFTs all in a single transaction with the help of the transaction manifest. So you can see in the same directory, there's a file called mintinitialNFTs.rtm. If you open it up, you should see the transaction manifest, which describe all the steps in the transaction to mint the NFTs. So if you don't see any colors in your file, just go into the file explorer on the left, and you can see that there's a VS Code extension file, RTM color, at the bottom. You can right-click and do install extension. So this is an extension that we made, and it adds colors to your transaction manifest just to make it more readable. So as you can see, on the first step that we do is actually create a proof that you own the admin badge. So we are going to be calling the create proof method on the account component, and we want to create a proof of the admin badge resource. So we are going to be so that's why we write the resource address of the admin badge. After calling this, it puts the proof on the authorization zone. So all the calls that you do after that, it will be authorized automatically. So then we do we call the method mint NFT on the component address, and we provide some different parameters. So that's it for the transaction manifest. But how do you actually run it? It's simple. You simply do resin run, and then you write the name of the file that you want to run. It's in the third directory, and it's the mint initial nfts.rtm. So you run this, and you can see in the log that it was successful, and you can see all the instruction that was provided. This is the same as we wrote in the manifest file. So let's verify that the component actually now owns the 3 NFTs. We've used a resin show earlier to show the accounts held within your account. But you can also put any address just to get information about it. So let's try to put the component address with resim show and provide the address of the component. So you can see that there's 3 resources of the NFT. You have the ID 1, 2, and 3, and you also see the data that they hold. So now let's try to buy one. We will start by buying a random one. So we do resim call method, and we want to call the method on the component address that we saved. And we want to call the buy random method. And remember, we specified the price for a random NFT to be 15 XRD. So we have to provide a bucket of 15 XRD. We do this by writing the amount that we want to send, comma, and the address of the resource that we want to send. In our case, this is the XRD. So again, success message. Just to verify, we will look at the resources within the account with resim show, and we provide the account address. So you can see that we received the first one. And it's now stored inside our account, and you can see that we've lost some XRD. Now let's try to buy, let's say we want to buy the third one. We can do it with resim call method, again the address of the component. But now we are going to call the buy specific method. And instead of sending 15 XRD, we are going to be sending 30. So 30, comma, and then the XRD address. And we want to buy the one with the ID 3. So we write this we write this ID that's provided in the README file. So let's verify that we received it with resim show account. And there you go. You now own the first one and the third one. So that's it for this example. Now we are going to be building something more concrete with NFTs. We are going to be building an event ticket system where each of the tickets will be represented as an NFT. So the NFT will hold some data, and it will have a flag to know if it has been used or not before, so that you cannot use the same ticket multiple times. So you will learn how to create resource with more complex logic, because we are going to be updating data on the NFT. You will also learn how to update flags on resources after the creation, and also how to update the data. So let's get into the code. So now we are at the 4th example. Open up the lib.rs file inside the source directory. So we are importing a module here. This will be used to hash some data. I'll explain it when we get there. So now when we define the event ticket data, each NFT representing the ticket will have a data for the seat row and also the seat number. And also, there's going to be a flag called used of type Boolean. And this one, notice that we have a macro on top to specify that this variable will be updatable. So that's it for the data of the NFT. Now for the structure of our blueprint, so the variables that will be present in each of the components. So we have the address of the ticket NFT. Again, this is to have access to the resource manager to be able to mint more of this resource. We have a vault for the token admin. Again, this will be this is so that the component is able to mint those tickets when someone asks them. We store the price for the tickets. We will also store on which epoch the event is starting. So you will also learn how to change epoch in the simulator. And finally, again, we have a collected XRD vault to collect the XRD that people are sending us. Okay, so the instantiator function, we ask for a price and also for when the event is starting. Inside this method, this function, we are first creating the component admin. This is like this last example where the person creating the proof of this badge will be able to call some protected method on the component. And then we are also creating a badge for the token admin. This will be more for administrating the supply of the token. So you will have to, the component will have this resource inside one of its vault, and they will create a proof of it to mint the ticket NFTs that we create in the next step. So again, to create a new non-fungible, we simply have to call the resource builder, and we call the new non-fungible function on it. We provide some metadata, and we provide the rule for minting. In our case, the badge that you need to show to be able to mint it is going to be the token admin stored inside the component. It will be locked because we don't want to change it later. And we also provide the flag updatable non-fungible data. That's to specify that we are actually able to change the data on the NFT. And we have also to provide a rule to say who is able to change the data, because we don't want people to just change the data without showing proof that they can do it. So again, just like the mintable is going to be the token admin. So the person showing the token admin will be able to update the data. And to learn about how to update the flags after creating them, we are actually going to restrict the withdraw. So this is, let's say that you create an event, and you don't want people to be able to send it to others. Like if they buy from you the ticket, they don't want you to sell it to other people after that. So that's why we have the restrict withdraw, and we actually set it to deny all at the beginning, which means that people are not able to send it to other addresses. They are not able to take it from their vault. But we provide, instead of writing that this flag is locked, we say that it is mutable, and to change it, you have to show that you own the token admin. So the component will be able to change this, to say that people are now able to transfer it. And we say that this resource is going to be, we are going to create it with no initial supply. So instead of returning a bucket, this returns us the address of the resource. And now we are initializing all the variables of the state of the component. And then we do the instantiate. We call the instantiate method on the state to get a local component. And again, before globalizing it, we're going to be restricting some methods. So we will have a method called allow resell that the component admin will be able to call to allow people to exchange this NFT to other people. So this method will allow will update the flag of the NFT. And all the other methods of this component will be allowed to everyone. So we add the access check to the local component, and finally we globalize it to get an address. So we are returning the component address that's created, and also we are returning the component admin badge, so that the person calling this function is able to call the allow resell after that. So let's go through the allow resell method, because it's pretty simple. It accepts a Boolean. Then inside it, if the allow resell parameter is set to true, the rule will be allow all. If it's set to false, the rule will be deny all. And then finally, we update the withdrawable flag by first taking a proof of the token admin badge inside the component vault with the authorized method, and then we are calling the set withdrawable on the resource manager of the ticket NFT, and we set the rule to the one that we defined depending on the allow resell boolean that the user provided. So that's how you update the flags. You borrow the resource manager from the resource address, and then you update the flags with different method calls. Before going into the enter event method, I'm going to go over the buy ticket. So the buy ticket method, it accepts a payment from the user as a bucket. It also accepts the user can specify which row and which seat number they want to have. And then it will return, again, it returns two buckets, one for the NFT and one for the change, if they send more XRD than the required amount. And now we are doing an assertion as the first step of this method. We are making sure that the event is not started yet by checking the current epoch and making sure it's less than the epoch at which the event is supposed to start that is provided by the admin. Then, we don't want multiple people to have the same seat. A way to do this is to actually set the ID of the NFT to be the hash of the row and the seat number. So that if, let's say that I select the seat row 10 and the seat number 10, I'm going to have the ID of my NFT will be the hash of those two numbers. And so no one else will be able to mint another ticket with the same seat row and number. So this part here is simply to calculate the hash of the two numbers. And then we create the variable ticket ID, which is set to the bytes of the hash. So we call non-fungible ID from bytes, and then we give the bytes. We send as parameter the bytes of this hash. And just like the previous example, to mint it, you first have to show that you have the token admin badge. So you do self.tokenAdmin, which is the vault containing the badge, .authorize, and again you borrow the resource manager, and you call the mint non-fungible method. You provide the ticket ID that we just calculated based on the hash of the seat row and seat number. And you provide the data that this NFT will hold. So the seat row, the seat number, and we set the used boolean to false. We store the bucket containing this NFT inside the ticket variable, and we return it along with the payment bucket, which now contains the change. Now, finally, the last method is the enter event method, that it accepts a proof of the ticket. Because we could have accepted a bucket instead, but this will be less secure because the user have to trust that the component will not, let's say, store this the badge inside the NFT inside their vault, or send it to someone else. So we simply accept the proof, so the ownership doesn't change. It stays, the ownership is still for the user. We do some assertion because the proof can be of any resource. So we make sure that the user sent us a proof of the right type. So we make sure that ticket.resource address is, in fact, the ticket NFT address, or else we cancel the transaction. And we make sure that the current epoch is greater than the start of the event. The next part is to get the data associated with this NFT. So we can get the NFT data from the proof by doing ticket.nonfungible. and we are storing it inside the non-fungible variable. And to get the data, we do non-fungible.data, and we store it inside the ticket data variable. And the ticket data variable has to be mutable because we are going to change the used boolean to true. Next, we are doing another assertion to make sure that it wasn't used before. And we are setting the used flag to true. When you do ticket.data.used equal true, this is only updating the data on the variable itself. It doesn't propagate the data change right away on the network. To do this, we actually have to borrow the resource manager of the ticket NFT address that we do here, and then we need to call the update non-fungible data method on the resource manager. And this update non-fungible data takes the NFT that we want to, the NFT ID that we want to update. So we can get the ID of the NFT that the user sent a proof of with non-fungible.id, because we want to update the same one that the user sent us. And then we provide the new data, which is ticket data that previously we changed the used flag. And again, we need to wrap this around self.tokenadmin.authorize, just to show as a proof that this component owns the token admin badge. And then again, if you're not familiar with Rust syntax, this is the last line because it doesn't have a semicolon. This is the same as doing a return statement like this. It's just easier to simply remove the semicolon and removing the return statement like this. So this means that, oh wait, actually, no. No, it's not returning anything, this one. So that's it for that's it for going through the code. And now we are going to be testing this blueprint, again by deploying on the local simulator. So you have all the indication inside the README file, and this is going to be more complicated. So I suggest to follow also on using the README, because we are going to be trying to also break the system at the same time to see how the Radix Engine handles it. So again, we are going to be exporting this Radix address variable. We need to do resim reset to reset the state of our local simulator. We are creating a new account with resim new account. We only need, from what is returned, we only need the account address just to be able to see the resources later. So we will export this into a variable. So if you're on Mac or Linux, you do export, and then we will call it account. And we set the value to the component address that was returned. And now we have to do resim publish with the fourth directory as the first parameter. So again, this builds our blueprint, puts it on the local simulator for us to call the functions on it. So this returns us the package address that we just published. I'm going to be calling the instantiate system function that we defined. So again, resim call function, the package address, the name of our blueprint, which is event ticket system, the name of the function we want to call, instantiate system. And remember that we ask for two parameters for this function, so a price and the epoch at which the event is starting. So for the price, we are going to be asking for 100 XRD, and the event will start at epoch 200. After running this command, you will see the new entities that were created inside this function. You first have the component that was instantiated. We will store it inside the component variable to refer to it later. And also, we are going to need the address of the admin badge, which is the first resource that is returned. So I'm doing export admin badge, and then I set it to the first resource address that was returned. And I also need to know the address of the ticket NFT, which is the third resource. So I save it also in another variable, so ticket NFT. I need to save them in variables because we will use the transaction manifest, and inside the transaction manifest, it actually refers to those variable names that I just created. So now I want to buy a ticket at row 10 and with the seat number 10. I can do this with resim call method. I put the address of the component, and I want to call the buy ticket method. Remember the price was 100 XRD, so we have to send a bucket of 100 XRD. And then I want to have row 10 and seat number 10. So this works. Now I should have this ticket NFT. Let's try to call this method again at the same seat and the same seat row and the same seat number. And you should see that we now have an error because you cannot have two non-fungible tokens with the same ID. And that's why we set the ID of the NFT to be the hash of the row and the seat number. Now let's try to send this token to someone. Let's say that someone pays me to buy this ticket. So let's create a new account, which will act as the second user. So we are going to be saving its. So we create a new account again with the resim new account command, and we are going to be saving its account address. And we also need its private key because we are later going to change the default account to this one. So I'm also going to save this into a variable, privkey2. And now I want to transfer my ticket NFT to this account. I can do this with resim, with resim transfer. How many tickets that I want to transfer? So 1. And the resource address of the ticket, which is stored inside the ticket NFT variable. And to which account that I want to send it, it's actually the account 2. So there's an error. That's because remember, we set the flag of the, let's go back into the code. And you can see when we defined the ticket NFT, we actually restricted the withdraw to deny all. And when you transfer your NFT, you are actually trying to withdraw from your vault inside your account to be able to send it to the other account. But it fails at the step of taking it from the vault, so because we set it to deny all. So let's try to change this this flag because we set it to mutable. We can do this by running the allow resell transaction manifest. We will first see what inside it what it does. Just like the previous transaction manifest, it creates a proof from the account component that you actually own the admin badge, and then it calls the allow resell method on the component, and it sets the allow resell flag, the take from vault flag to true, so that people are able to withdraw from their account. So let's run it with resim run, and then the file of the transaction manifest. So inside the for directory and the allow. Hello? Hello? Okay. Okay, so finally, you call the allow resell with a boolean of true. And yeah, so that's it for the transaction manifest. So yeah, we actually run it with the resim run, and we specify the allow resell.rtm. And it says that it was successful. So hopefully now, let's try again to transfer the token with the resin transfer command that we tried earlier. And now you see a success message. So I'm going to run this resim show, and I put the address of the account, just to be able to see that. So now you see that you actually doesn't have the NFT anymore. So just to verify that you actually send it to the second user. So let's continue through the README file. Let's try to enter the event. So now that the ticket is owned by the second account, we will have to call the enter event method from this second account. So to do this, we will set the default account to the account 2. So we do this with resim set default account. This method requires us to provide the address of the account and its private key to be able to sign our transaction. So now you should see that the default account was updated. And so let's try to call the enter event method by providing our ticket NFT. So let's do resim call method, the address of the component, the method name, which is enter event. And now we have to show a proof that we own this ticket NFT. This is just like sending a bucket for the syntax. So the amount that we want to create a proof of, so 1, comma, and the address of the resource that we want to create a proof of. So in our case, it's stored inside the ticket NFT variable that we set earlier. So let's see the result. So we get an error again. What? Yeah. So that's because the current epoch is not didn't start yet. The event didn't start yet, because remember we set the epoch at which the event is starting to be 200. So we actually have to change the epoch on the simulator. How do we do this? Is with the resim command and set current epoch, and we write 200 because we want to set it to 200. So you should see a message, current epoch set. So now you should be able to call this enter event method again. Oh. Oh yeah. Oh yeah, when I tried to set the default account, I actually put the account number 1, but it's number 2. So like this. Now I should be able to call the enter event like this. So we get a success message, and everything is working now. So this is it for this example, and now we are going to go through another round of questions. So go ahead and go scan this QR code or go on slido.com and enter this code to ask us some questions. Someone is asking, can you please compare objects from traditional object-oriented programming to resources? what are the main conceptual differences? I wouldn't compare the resources to object-oriented programming. What I would compare object-oriented programming to is actually our blueprint and component way of doing things, whereas the blueprint is actually like a class, and the components that you instantiate from this blueprint are actually the objects that you, just like when you have a class and you instantiate an object from it. So Scripto handles operation with floating points, or how do the fungible tokens are fractionated. So like we saw earlier, like you cannot have floating numbers inside Scripto, and this is because in distributed ledger it's a little bit complicated because different nodes can have different hardware and they can handle floating points differently, and we want all the calculation to be the same on every node. So that's why we created the decimal type, which is simply representing the floating number with as an integer and the number of decimal places it can hold. So that's why when you create a resource, you can specify the divisibility of the token. When you say that it's divisibility 0, it means that you cannot fractionize it. If by default, if you don't provide this divisibility flag, it will be 18, and you will be able to send up to 18 decimal places of this token. So this is the same thing with the decimal types that we created. So if the gumball price is a decimal and the token has divisibility 0, where along the way would it fail? It would fail when you are trying to take from your vault, because you will try to get an invalid amount of tokens from this vault, and the transaction will simply fail. As a developer, will I be able to access metadata from blueprints, components, and transactions? Yes, because everything that is run on the ledger will be public, and it will be accessible through APIs. At the moment, because it only runs on the local simulator, you don't have access to that. But if you deploy it on the public test environment that we created, you can actually query the API to get information on the blueprints, the components that were created, and also have information on different your transaction that you run. What happens if someone instantiates the component over the max limit of decimal type if there's a limit? I think they're referring to the previous example, the gumball machine, where the user is providing the price for gumballs. And so it will simply fail the transaction, because you can, if you send if you try to send a decimal too big, it will simply fail because it's not valid. So if you have any more questions, simply scan the QR code, and I will try to answer it. Can the Radix Engine access cloud services like a SQL Server database, for example, to manage inventory? Not directly. When you all your Scripto code can only access data that's on the ledger, but you could build an Oracle that actually gets some data from an external SQL server, but that's a different problem to solve.
Might actually comment on that one, because this is an interesting point. I think for people that are new to the space, you understand this. The Oracle pattern is actually a really important one, because you often do have these situations where you want to have a link between an off-ledger system and an on-ledger component in some cases. And so oracles are the way in which you can do that. And it can go both ways. It can sort of either make data from off-ledger available within the state of a component, and from there, then other things can access it natively, or go the other way of saying, registering a request within a component, the off-ledger system sees that request and then can fulfill that back again. So we actually just had a developer challenge. We've been doing these every month. We just had a developer challenge that finished up about oracles. And so there's some really cool examples from our community of people that have built different kinds of links between on and off ledger systems via Oracle components like this.
So we are going to take a short break before going to the last example for the decentralized exchange. So see you later. Welcome back, everyone. So for this last example, we are going to go through a more concrete example. This is going to be, we are going to be building something that's known in the DeFi space. So we are going to be taking the Uni Swap, which is a decentralized exchange that allows people to provide some liquidity and allows them to swap some tokens. So we are going to take this project and bring it to Scripto. So you will, at the same time, during this example, you will learn how to compose component calls. Like we used the transaction manifest earlier, but it wasn't really communicating with it wasn't like a really complex transaction. Now what we are going to be doing is we are going to be instantiating the decentralized exchange, and also the gumball machine example that we saw earlier. And we will do a more complex transaction by first buying a gumball and exchanging it for some BTC token from the decentralized exchange that we are going to be building. So you can see the diagram of the blueprint that we are going to be creating. So there, we are going to provide an instantiate pool function to instantiate the pool component. People will be able to add some liquidity by calling the add liquidity method, and they will be able to remove liquidity also. And finally, users will be able to swap some tokens by calling the swap method. So you can see this is Uniswap on Ethereum, and this is the swapping functionality. You can see how complex it is, and I wouldn't be able to explain to you how this works in only 30 minutes. So let's see how it looks on Scripto. The same functionality for swapping tokens is really now really simple because you don't have to, in the previous example that I saw on Solidity, you have to do a lot of checks, and you have to handle some edge cases around the assets and around the language itself. So, and like I said, we are going to be testing the Radix Swap, our decentralized exchange, by doing a more complex transaction. So we are going to be withdrawing some XRD from your account, buying a gumball with this XRD, and then the gumball that is returned, we are going to be sending it to the Radix Swap component to get back a certain amount of BTC, depending on the quantity of tokens and the pools on this component. And then finally, we are going to be inserting those Bitcoin inside back into your account. So returning to open up VS Code again, and go into the 5th example. Open up the lib.rs file that contains the blueprint definition. For the structure of the blueprint, where we define the variables that will be present in each of the instantiated component, we are going to keep track of the resource address of the liquidity provider token. The liquidity provider token is a way to track what percentage of tokens a user provided to the pools to be able to calculate how much to give them back when they withdraw, so that hopefully they accumulated some fees while people did some swaps. We also have a vault to hold the liquidity provider minting badge, and this will be used to mint more of this LP token. We have a pool of token A, which is a vault, and also a pool of token B, which is another vault. And finally, we are storing the fee that the user will have to pay whenever they are swapping tokens. So for the instantiator function, the user will have to provide a bucket of token A and a bucket of token B. These will be the initial supply for the pools of tokens. And they also have to provide the initial supply for the LP token. So this is the number of LP token that they will receive for this, the quantity of tokens that they provide. And they also have to provide a fee as a decimal. The first step we do in this function is doing some simple assertion, like making sure that the buckets that the user sent us are not empty, or else it will be creating some problems. And then we make sure that the fee is a number between 0 and 1. The next step is to create the badge that when you show it, you are able to mint more of the LP tokens. So again, we do this with the resource builder, and our token that we're creating is going to be fungible. So we call the new fungible function. We provide a divisibility of 0 because we don't want to be able to split this token. And we put some metadata, and we initialize the supply to be 1. So this returns us a bucket containing this one token, and we store it inside the LP mint badge variable. The next step is to create the actual LP token. Again, we call the resource builder's new fungible function. We provide some metadata, and we provide the rule for to specify who is able to mint and burn this token. In our case, it will be the LP mint badge resource that we just created before. And we specify that the initial supply will be equal to the initial supply that the user provided in the parameter of this function. We store it inside the LP tokens variable. And we initialize the state of the component, again, by assigning a value to each of its variables. So we store the resource, the LP token that we created. And also we initialize the 3 volts with the buckets that we just initialized, we just created. And we set up the fee. When we have the state set up, we can call the instantiate method, which returns us the local component. And because we don't need to protect any of our methods, we can globalize it right away and return it to the user instead of adding some authorization rule like we did before. And we are also returning the initial LP tokens that we created, so that the admin can then withdraw their liquidity that they just provided later. So let's start by, I'll start by explaining the swap method. So go down the file and find this swap method. It accepts a bucket that we call input tokens, and it can be either of type the token A or the token B, because we will do some different step depending on which one it is. And we will return a bucket, which will be of the other type. So if they send token A, we will send token B based on some calculation. So inside this method, we first calculate the fee that we are going to be taking for this transaction. So we take the fee that the admin, the instantiator set up, and we multiply it with the amount of token that the user sent us. And then we store we also store the amount inside this input amount variable. This is just for debugging purposes later. It will be useful when we are going to do the composing the calls, just to see where the transaction is at. And then we borrow the resource manager for the token A and token B. We will need it also for debugging purposes, just to output the information about the exchange that you are doing. And then we check which token the user sent us. If they sent us the token A, we first calculate the amount of token B to give using this formula here. And we store the amount inside this variable called B amount. We then insert the input tokens inside the A pool, and then we return. We take from the B pool the amount that we just calculated, and this is returned back to the user as a bucket. So the other branch of the if statement is in the other case, if the user sent us B token. So it does the same thing, but with the other token. So this is it for the swap method. Let's go to the add liquidity method. So it accepts a bucket of token A and token B, just like when the admin instantiated the component. And we actually need to keep the ratio of A tokens and B tokens and the two pools the same as it was before adding the liquidity. So that's why we need to do a little calculation here. So we get the ratio of A token the user sent us and the ratio of B tokens. And so that the ratio doesn't change, we checked if the A ratio is less than the B ratio, we are going to put the full amount of A token inside the A pool, and we are only going to take a portion of the B token to put inside the B pool, depending on this ratio. And we do the inverse for if the user sent more B token than A tokens on this other if branch. And then we store this the actual ratio that we kept, and we also store the remainder of the token that the user sent us in excess, so that we can give them back. Then we get the resource manager from the liquidity provider token resource definition that we stored inside the state here. And we calculate the amount of liquidity provider token to mint by taking the total supply of LP token and multiplying it with the ratio that we just calculated previously. Then we mint the liquidity provider token by, again, we need to show a proof that we own the badge that is allowed to mint those tokens. We do this by calling the authorize method on the vault containing the badge. And then we simply have to do, we get the resource manager and we call the mint method on it with the amount of supply to mint that we calculated. And then we return the LP token that we minted and the remainder of the token that the user sent us in excess. Now, for removing liquidity, it's actually more simple because you only have to essentially the user send us back their LP token. And we, depending on the amount that they send us, the ratio between the amount that they send us and the total amount of liquidity provider token tells us how much of A tokens and B tokens to give them back. So the first step is to do an assertion to make sure that the user sent us the right token. So we make sure that we do self.lp resource def, which is the actual address of the LP resource. And we make sure that it is the same as inside the bucket that the user provided. If this fails, the transaction the complete transaction will fail, and everything will be reverted back. We then calculate the share of LP token that the user is sending us. So we divide the amount of tokens the user is sending by the total supply of LP tokens, like I just said before. To get the total amount of LP tokens, you can simply query it on the resource manager. So you first get the resource manager with by calling borrow resource manager with the address of the liquidity provider token, and then you call the total supply method on this. And then you withdraw from the A pool and B pool depending on the amount of share that they owned on those pools. So we take the total number of tokens in the A pool times their actual share. And then we do the same thing for the B pool. Then we want to burn those LP tokens because we will not need them anymore. And to actually decrease the supply for the next time we calculate, the next time someone calls this method so that it's the right calculation. So again, to burn it, you have to prove that you are allowed to burn it by showing that you own the badge allowed to do this action. So we do again authorize on the LP Mint badge vault. And then we simply do LP tokens, which is the bucket that the user sent us, .burn, which burns the tokens. And then we return the A tokens and B tokens that we return them back to the user. So now that we are done with explaining the code, we are going to test it. To prepare your environment to test it, like I said earlier, we are going to be instantiating in Gumball machine. We are going to be instantiating this Radix Swap example, and then we are going to do a transaction manifest, putting together those two components. So to set up your environment, I created some script to help you. So if you're on Linux and Mac, you can do source, and then you call the setup composability.sh. So this script goes into the Gumball machine example, builds it, put it on the local simulator, buys 3 Gumball that we will use as liquidity when initializing the pools. And then it goes back to the decentralized exchange directory and publish it, and it saves some variables that we will use in the transaction manifest. If you are on Windows using the PowerShell, this is the command that you have to call. Don't forget to follow the steps mentioned in the main README file if you are using Windows, or else you will get problems running this file. And now, to run this example, we are going to be running the composability example.rtm file, which is just like I showed here in this diagram. So I've put this diagram into a transaction manifest, and you can see it in this file. So the first step is to withdraw some XRD from the account to be able to buy a Gumball. So we call the withdraw by amount method on the account component. This method requires us to provide the amount that we want to withdraw. So we specify 25. And we need to provide the resource that we want to withdraw. So in our case, it's the XRD resource. So then, this method returns a bucket that is put on something that we call the worktop. So whenever a method returns a bucket, all of its content is put on the worktop. And then you can, like in our case, we are going to take those resources, put them in a new bucket to be able to send it to the Gumball machine. So to take the tokens from the worktop, we call the take from worktop by amount instruction. we provide the amount, so 25. And the resource, again, is we want it to be XRD. And then we provide the name of the bucket, which will be XRD payment. Then we can call the buy gumball method on our gumball machine, just like we did earlier, but now in a transaction manifest. And we provide as argument the bucket that we just created in the previous line, XRD payment. This, again, returns the bucket, and its content is put on the worktop. So we have to take it and put it inside a new bucket, because we will want to send it to the Radix Swap component to swap it for another token. So again, we do take from worktop, but now we take only one. And the resource that we want to take is the resource gumball. And we store it inside a bucket called gumball. And finally, we call the method on the Radix Swap component swap with the gumball bucket that we just created. So at this point, if everything worked correctly, this returns us a bucket of a certain quantity of Bitcoin, of BTC, depending on the ratio of the tokens in the two pools. So if you've used Uni Swap or another decentralized exchange in the past, you would know that whenever you do a swap, the price of the assets changes depending on how much you traded. So the more the more you buy, the more the price will change. So it's always a good thing to make sure that you receive the amount that you are expecting. So that's why we do an assertion in this file. We make sure that we get at least 10 BTC by writing assert worktop contains by amount. And we make sure that we have at least 10 of the resource BTC. And then finally, we will take those BTC token and insert them back into our account by calling the deposit batch method on our account component. So let's try to run it. So again, to run a transaction manifest, you do resim run, and then you provide the file for the transaction manifest, which is composability example.rtm. And you can see this is why I wrote some debugging information in the gumball machine example, and also in this the Radix Swap example. This is to see the different step in the transaction. So you see, we are starting by buying a gumball, and then we are swapping it for some BTC, and we can see how much BTC we get actually. And let's try to run it again. You can see that we now get less BTC. This is, I explained this is because you are, whenever you do a trade, it's going to change the supply of both of the, it's going to change the ratio between the two pools, and thus the actual price of the assets. And let's try to call it one more time. And you can see that we are buying one for less than 10 BTC. And if I open the terminal more, we will see that it failed. The transaction failed, and everything got reverted. And this is because of the assertion that we put here in the transaction manifest. So even if before that you bought a gumball with some of your XRD, but after that it fails, like everything will roll back, so you will not lose those 25 XRD that you've used for the gumball, actually. And what's really nice about the transaction manifest is that we did all of this by simply writing a text file. If you would do this on Ethereum, for example, you would have to write all of this logic in code on an actual smart contract, and you will have to deploy this on the network before calling it. And if you then wanted, like 2 weeks later, to change this, the amount of BTC that you want to make sure that you have to, let's say like 20, you would have to update your code on your computer and then redeploy it on the ledger on a new smart contract, and then call this new smart contract again. So first, it costs a lot because you have to deploy some code on the ledger. And also, it takes more time because you have to rewrite your code. With Radix, now you have the transaction manifest, which makes it really easy to do those composability in your transaction. And you can do really complex transaction with a lot of lines and only a text file, which is really nice. So now that we're done with this example, we're going to go through the final questions. So if you have any questions, go on Slido and enter the code that you see on the screen, or simply scan the QR code, and I will answer your question. So, someone is asking about the previous example. Can I instantiate a board gumball club without an account? Probably they are asking this because I was creating an account before instantiating the component. And you don't need an account to publish a component. Only when you are taking some assets from your account and putting some back into it. What advantages does creating and transacting NFTs in Radix have over Ethereum, Solana, and other platforms? So, first, it's more easy. You don't have to implement the whole logic of the resource yourself. Like on Ethereum and Solana, you have to, on Ethereum, you have to deploy a complete smart contract just to represent the asset. And it would actually hold a balance sheet of each of the user that each of the wallet addresses that have this resource. And you also have to implement yourself the logic for changing the ownership of this token, and also fetching the balance of someone, for example. So this takes a lot of time, and also there's more room for introducing maybe some bugs in your code.
Yeah, this is also an interesting one I wanted to add a little bit to, because it speaks to the kind of the difference in how this stuff works pretty deeply. Like the idea of what we're trying to do with resources in a lot of cases is separate the asset itself from the business logic that interacts with the asset. And this is a really important pattern. If you look at NFTs that are issued on Solana and Ethereum and so forth, there's this tendency to embed the logic of the thing you're trying to do with the NFT in the NFT token itself. So for example, if you want to build a game that has an NFT, what you're usually doing is building a contract that implements all your game logic and keeps track of the token balances, and it's all kind of wrapped together. And what this means is that there's very little modularity, and every time someone has a new idea for an NFT, it's like, all right, now I have to think about how is this version of an NFT going to be written to implement this kind of game or this type of exchange or whatever it is. So it adds a lot of friction to the process, and it also adds a lot of risk to the process, as Clement was alluding. But the other thing that's kind of interesting about it is that what it means is that if you've got wallets or other pieces of software that are connecting to the ledger, there's no way of being able to see what an NFT is, if you know what I mean. It's all just connecting to different smart contracts and someone saying, look, this is adhering by this new standard that we've come up with. Like, every time there's a new idea for a game idea, they're trying to come up with another ERC standard. Say, like, okay, for this type of game, you're going to interact with this contract in this kind of way, and your wallets have to understand that, so you end up building custom wallet software in some cases. In our case, all the NFTs are just resources, and all wallets are going to know how to interact with those things natively. And again, this is looking a little bit ahead to the wallet that we're building, is that you'll be able to see, oh, this is a non-fungible token. It has certain metadata. It has certain behaviors because it's built into the platform. There's no, if someone comes up with a great new idea for using NFTs in a different way, they didn't have to re-implement NFT. It still works with the existing wallets. It still interacts with everything else on the ledger in the same way as any other resource does. However, you still have the power to build the game logic. It's just that now you keep that outside the asset itself in a piece of component logic. And for example, that component might have the badges that are needed to interact with the NFTs. So let's say you had the CryptoKitties example from Ethereum days from a couple years ago. If you wanted to have something where you needed to be able to like update the metadata on an NFT to indicate that your CryptoKitty had leveled up, well, all that means is that you give your game logic component a badge that says you are allowed to update the metadata on this type of NFT. You didn't have to build that NFT. You wrote game logic and then had that give that rights to interact with the NFT. So that separation is like the philosophy overall that we get to with Scripto, with a lot of different things, is always think about separating your assets from your game logic. And if you do that, it becomes much more logical, much more universal and powerful.
For the next question, someone is asking about the output format for the resim comments because it's not really parsable. And this is because it's not, resim is supposed to be used for testing purposes. If you want to parse, let's say, the result of a transaction, or if you want to fetch the list of components on the ledger, you would actually use our public test environment API, which returns the results in JSON. Or when we will have the AlphaNet and BetaNet, you will simply query the network to get those information. So resim is simply to quickly test your code on your local machine. Someone wants more information on the benefits of the transaction manifest. I think Matt would be able to give better explanation.
Yeah, this is an interesting one. The transaction manifest was one that happened a little bit later in the development process, and when we came, it initially started out as like, well, we're reformulating how all this stuff works, which means we have to go to a different transaction design. And as we started going through it, we realized, wow, this isn't just something we have to do; it's a really powerful thing on its own, because I think. A couple things offhand that come to mind that make it so cool is, one, the composability aspect of it, which Clement has mentioned a couple times, the idea that you can put together multiple calls in one transaction and have it committed atomically rather than having to deploy, rather than have to plan ahead of time for what you want to compose together. That's pretty unique capability. Another one that's related to that is the fact that you can do those sorts of things on the fly, which is kind of cool. If you imagine being a front-end developer, so you're not even necessarily, maybe you didn't even build the components you're interacting with. You're just building a great web front-end that knows that's going to be building transaction manifests that interact with different things on the ledger. A front-end developer could build transaction manifests that would, in real time, compose transactions to do different things. It would say, hey, right now, you're getting a better exchange rate from this exchange, and therefore I'm going to build a transaction manifest that uses that to do this other thing over here. You didn't have to write any smart contract logic for that at all, which means I think it opens up the range of developers. They can just really focus on user experience, which I think is kind of cool. And the last thing I'll mention about the transaction manifest, which we haven't really talked about, is just the transparency aspect of it. I wish I could make this tangible, and this will come a little bit later at the wallet, but if you've ever done a transaction on Ethereum, what your wallet is showing you to sign is a hash. It's just, this is a description of the message you're sending to a smart contract that's hashed. You're going to sign that. And it's up to you to know what that hash means. You have very little transparency what's going on. Like basically, it's up to you to go, well, I could audit the smart contract that I'm interacting with and say, okay, well, for this call, this is going to be the result. But obviously, no one's actually going to do that. So you get, a lot of times, you get people that get exploited on Ethereum because they don't know what they're signing in the end. The transaction manifest is cool because this is nearly human parsable on its own, and it's very easy for client software like wallets to and then take that up one more level to be able to directly show the user, hey, what you're signing is a transaction that's going to result in these tokens leaving your account, these tokens going into this other thing. You're going to be interacting with these 4 Dapps. And you can be very intuitive about presenting that to the user in a way that makes it very difficult to scam people, because it's virtually impossible they would miss, oh, these tokens are actually going to some account that I didn't expect. That's weird. I'm not going to sign that. So I think that alone is going to be really powerful for making DeFi a lot more palatable to the mainstream user and a lot more user-friendly. And this again, this is stuff we're working on with our new wallet design that'll take advantage of some of these things.
Someone is asking about the worktop. Is it only used for managing the resources and buckets, moving between components? Well, this is one of the use, but you can also create proofs from your worktop. If instead of wanting to change the ownership of those tokens to the component, you can create a proof, just like we did in our previous example, just to show that you own those resources without actually giving the component the right to store those tokens somewhere or do anything with them. What is the path from development to production? So from resim to a remote infrastructure. Do you want to take this question?
Yeah, I can. The idea is it actually should be about as low effort as possible. The idea is that RESIM is just kind of giving you these really simple tools for you to be able to iterate in this local environment. Ultimately, what you're going to be doing is the same things that the simulator environment that you're interacting with that we've been doing today is basically at the top layer is doing the same thing that the public network will do. It's deploying to a file system-based thing on your computer, which is running actual Radix Engine and validating transactions and so forth, just like the real thing will on the network. So really the only difference is sort of your targeting. Ultimately, rather than targeting your local environment and deploying there and doing transactions on that, when you go to production, you're going to target the real network, deploy there. There'll be some slight differences because when you deploy the real network, you're going to have to actually submit a transaction, sign it with the wallet, and submit it. But ultimately, this actually needs to be framed out a little bit, but probably RESIM will still be used. You'll be able to redirect the RESIM commands against the public network. It's just sort of a convenient tool. We may also have kind of a little builder thing that allows you to kind of push things to the wallet and do some stuff like that. But it won't feel like a wildly different experience going to production. Basically, the idea is the way I imagine the flow being for a typical developer would be, build your first prototypes, kind of rapidly iterate on your design in the local environment. And that local environment option is going to remain even after we launch them in network. It's not like this dies. It's like this is a great place to start development. Once you're feeling like, yeah, okay, I've got the major pieces of functionality. Now I need to really understand how this is going to maybe interact with other things on the network. Maybe I want to have multiple testers. I want to connect my front end to it. This is what test nets are going to be good for. So now you retarget, deploy to the test net. This will look and feel just like the real network, but real state isn't at stake. The tokens are fake. Nothing matters. So do kind of your more heavy-duty testing on a test network, and once you feel really confident there, now you move to your mainnet deployment, and now it's live for the world to really interact with. Something else, kind of the next step on the life cycle is that we are working on trying to implement versioning and updating of things on the public ledger. This is a sticky problem because it's not simply a matter of like, all right, you replace this code with the new code because there's all this existing state and people that are relying on things. So there's a versioning scheme that we're going to have to work on. This probably will not make the first release. But we do want to get to the point where you can update blueprints that have been deployed to the ledger long term.
Great. So that's it for the workshops. So I hope this gave you a good introduction on Radix and Scripto. And if you have any more questions, just join the Discord community or Telegram community, and we will answer you. Thank you.
Yeah, let's have a hand for Clement. Yeah, thanks very much, Clement. For those of you that stuck around the whole time, thank you very much for being dedicated. I hope this was all very rewarding for you to sit through the whole thing. Like you guys are the people that every time we do one of these events, whether it's a large one or a small one, we get people that come at us that become really passionate members of our community and carry the project forward. So we really appreciate you spending the time, and we hope you will join that community. If you haven't heard it already, the flyers are on the table. On the back side of that, you'll see QR codes. That'll link directly to our Discord and Telegram communities. Discord in particular, I really recommend you jump in there. It's a really, really great community of people that are working with Scripto, helping each other out, building great things, sharing what they're doing, and forming groups to go pursue projects together. So would love to see you in there. Clement's going to be in there. I show up sometimes in those channels as well. Beyond that, so we're at a little past 4:30 right now. The after party is going to be starting here at 6 in about an hour and a half. Feel free to just hang around here until then if you want. If you want to go someplace and come back, that's cool too. We're opening it up to kind of more people, so there are going to be some other people probably showing up at 6 o'clock. We're going to have an open bar. We're just going to be kind of hanging out, so feel free to stick around, or if you got other things you need to do this evening, that's fine too. But again, thanks so much for coming. And I also, if anyone else just wants to ask some questions, I'll be around here for a little while. So thanks everybody.